What does it take to cut a ship into two halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. Every 6 years, at the very least, every plane has to clear its schedule for an important job. It's a major inspection, known as an IL check. How much work does this involve? 25,000 man-hours. It's one of the most complicated pit stops in the world. Lufthansa Technik Malta is an expert in aircraft maintenance. Day one of a huge new project, the Airbus A330-300, official name Kilo Romeo. It's over 63 meters long and almost 17 meters tall. Kilo Romeo is used for medium to long-haul routes. The Airbus's wingspan a good 60 meters. And it travels at a maximum speed of 875 kilometers per hour. The complete overhaul takes 40 days. During this time, a team will dismantle the entire cabin, which includes the seats, kitchens, toilets, wall panels, and floors. No matter how small the component, the inspection is thorough. Clean, check, and repair or replace. Once everything is outside, the team checks the airplane's structure for damage, right down to the last screw, inside and out. At the same time, engineers perform any repairs needed on the wings, landing flaps, and engines. Lufthansa Technik Malta checks the safety of fleets from several different airlines. At the start of any new inspection, project manager Daryl Heyman can never be sure what kinds of problems he'll discover and whether he will manage to stay on schedule.
Once we have everything stripped down, we kick into an inspection phase, and from the inspection phase we will know exactly what we're looking at. It is surely a challenging job.
The first big challenge is getting the gigantic aircraft into the hangar. Engineer Patrick McAuliffe takes command. The blue work platforms in the hangar are carefully adjusted to Kilo Romeo's dimensions. The 200 million euro jet has to park right in the middle of them. Routine for the 29-year-old engineer. Even so, he needs every spare pair of hands in the hangar.
You will need to be like, you have like 10,000 eyes on each person, because a slight crack it costs thousands of dollars. Stay one left, one right. Everything is clear? Okay, good. So we will be inside in a few minutes. Step one.
Despite different nationalities and noise from the turbines, communication has to be as simple and clear as possible. Patrick's instructions are standard marshalling signs. Just like parking a car, reverse parking a plane relies on turning the wheel at precisely the right time. The entrance to the hangar is a critical point. From here on, Flagman Patrick only has minimal tolerance on either side. Only if Kilo Romeo stays on the yellow line in the middle will it fit into the hangar.
Very close, less than half a meter, you know, so it gets very close.
Patrick spots a problem. Kilo Romeo is moving at a slight angle, next to the guiding line.
A little bit misaligned. It needs to be a little bit to the right.
The pit stop is on a very tight schedule. In just 40 days, the Airbus has to be ready for safe takeoff, or so says the flight plan. Any delay here in the hangar means potential cancellations for the airline and its passengers.
Everything is according to plan, so hopefully we'll continue and finalize this towing procedure.
The wings are approaching the platforms. They did it. The plane is in position.
As it is. Brakes on.
Good job, boys!
All the area had been clear. Nothing had gone wrong, so everything was perfect today also. Another job done.
So the first successful milestone of this layover.
Exactly, first milestone. Rehangering.
A complete overhaul in 40 days. This requires 5 teams: cabin, engines, cargo hold, electronics, and structures.
So good morning, everyone. We're day 1 of 40 for the next incoming project on Kilo Romeo. The clock is ticking to achieve the 40 days. We need to start now, so let's go and let's do the job and make it in time.
The only way to stick to the schedule is for all departments to work at the same time. The engines team starts by removing the turbines. To do this, Patrick has to prop and lift the aircraft. This allows the lift truck to fit underneath the turbines. To lift the plane, he positions 3 jacks, like the ones you find in a car workshop, but much, much bigger. He places one at the nose of the Airbus and 2 under the wings.
We check that the nose landing gear jackets, everything is okay. The lock nuts are tight, so if there is any movement, the nut will be in place. Kevin, we start lifting the nose. 1.3. 0.2.
Patrick starts by lifting the aircraft's nose. Then, the team slides the jacks under the wings.
We're aligning the main landing gear jack that goes inside the jacking adapter.
Kilo Romeo weighs 170 tons. If the jacks aren't positioned correctly, they'll slip and pierce through the wings.
Alberto, Andrea, and we have Adrian on the nose jack that they will need to be synchronized because right now the aircraft is stable, it's 0 degrees, and we're gonna lift all the 3 jacks together. Alberto, Andrea, mains up.
Both operators have to lift the wings so they remain exactly parallel. If one side rises quicker than the other, the plane will tip over. The massive lifting platform elevates Kilo Romeo 7.5 meters up from the ground. Its 170 tons are balanced perfectly between the 3 points. Now, the lift truck can fit under the engine.
A lot of job had been done and a lot of more pending work to be done later on this check.
10,000 individual job cards, 25,000 man-hours. Project manager Daryl has already performed general overhauls on over 100 different planes, and yet every plane brings new challenges.
So in the next couple of days, we'll be seeing a different aircraft. So yes, it will be interesting for one to see from when the aircraft arrives into our facility, into the hangar, how the aesthetic of the maintenance event changes.
To stick to the plane's delivery deadline, Daryl has to keep his eye on all 5 teams at the same time, both outside and inside the plane. James Sheed is in charge of Team Cabin. His job, completely dismantle the interior. inspect it for faults, and then place everything back where it belongs.
Carpet, guys. So upholstery, we start removing all carpet. How much time do you need to? At least 2 hours should be finished, the carpet. So then we need all cove lights in area 7, sidewalls and dados to be removed today.
James coordinates 15 tradesmen and engineers. All of them work in sync, which is why they truly depend on each other. A single delay, and the entire pit stop schedule would fall behind.
Everything is happening at the same time. I have to go around the cabin all the time to see that everything is going smoothly and no problems are being held from an area to be removed. That's why it's a little bit complicated.
Before things can progress, the seats have to be removed. That is Jason Shikluna's job. The more comfortable the seat, the heavier and bulkier it is. A business class seat takes around 6 times longer to remove than an economy seat.
You have this here. Okay. Just have to go. Move it back more. Okay, like that. Good. Mainly, this is the back shell. All power supplies are here. This will be connected to the seat, where for every seat they have actuators, motors. Mainly, they have 5. Every motor for each movement of the seat.
Around 750,000 passengers have traveled the world on these seats. The main thing they leave behind? Dirt.
I'm always dreaming to find maybe a diamond, you know.
Jason has just 3 days to remove the 238 seats. His seat shop is one of 13 workshops inside the hangar. Each department performs all their own repairs on site, which saves an incredible amount of time. Lufthansa Technik doesn't just look after Lufthansa aircraft. Airlines from all over the world bring their planes here for a general overhaul. For Jason, this means ever-changing kinds of seats, along with their various defects.
You know, every seat is a jigsaw puzzle. So every part of the seat has a number. If you need to, if you have something broken, you have to check on manuals, check that part number. Then you will order and replace any parts that are damaged.
An essential part of every check is a thorough safety assessment of the seats and belts. Jason only replaces the upholstery where necessary. Inside the hangar, the teams continue dismantling Kilo Romeo. 70 people work simultaneously on every part of the plane. The structures team is inspecting the Airbus's steel frame. Every single bit of corrosion must be identified. Patrick and his team are still removing the turbines. An assessment of the hoisting under the engines is a mandatory part of every IL check.
We need to work simultaneously, all together. Everyone will be take his chain blocks and everyone works together.
To access the engine hoisting, Patrick's team must first remove the turbines. Four chain hooks help them out. Using synchronized levering movements, they slowly lower the engine. Once complete, the engineers can finally access the hoisting. This is what holds the engine to the wing. It has to be checked every 6 years.
So this is the forward inboard mount. This big attachment. As you see, it will get attached later on to the fan frame, and also on the other side, still the same.
The mechanics use levers to lift the truck and its struts.
All together.
The lift truck uses the same principle as a forklift.
And you
Keep going.
lower down.
Keep going.
All right. 1, 2, 1, 2.
Once the truck has reached the right height, Patrick detaches the engine from the wing.
One, two.
Finished. The struts are now at the same height as the turbines. The team detaches the connection to the wing. Now the lift truck is holding the full weight of the engine, 6 tons. One of the plane's heaviest components. Success for Patrick.
So another engine had been removed, another job is done. Everything went pretty well, everything is okay.
Another task for the mega pit stop. Checking the outer shell for damage caused by bad weather. Even the tiniest bit of damage from hail or lightning can pose a safety threat. At the same time, under the plane, mechanics are bleeding the fuel tank, so they can inspect it from the inside later on. In the cabin, things are still being dismantled. Project manager Daryl is supervising over 500 individual job cards just for the interior.
Working in maintenance, aircraft maintenance, it is something which keeps you always on the edge, always concentrated. You need to be always concentrated, and it's a nice and interesting job that makes you feel proud if you're working in it.
Daryl and his team make sure that passengers can feel safe. That is always the #1 priority, even more important than costs or the pit stop schedule. After 750,000 passengers, a thorough clean is well and truly in order. The seats have all been removed and are in the workshop. The cabin team is now removing all the carpets, flooring, and cladding from inside the plane. Only now can Team Boss James start concentrating on the trickiest part of the disassembly process. The equipment in the middle, in other words, the kitchen and toilets, are blocking the workers' path.
Mainly the items that are repairable is the lamination here, which you can see several damages which can be repaired, and new lamination will be installed.
The term monuments refers to components that are assembled as a group.
This does not split, so it's very heavy to get it out. So you have to be exactly with the door level, and you need at least 4 to 5 guys because it's really heavy. Mela. So first lift a bit up and go backwards. Wait, stop there. So now we have to tilt it forward and then you put. Slowly, slowly. Lower it down from the front. Okay, so let's go straight. And we have to tilt up. Yes, tilt, it's all right. Lower it a bit. It's okay at the top. All right. Yeah. So go forward to the door. Lower it a bit down more. So I have to go straight like this. This small, yeah. Go straight. Wait.
The part is stuck, which means it is blocking the door for other workers. James needs a speedy solution, otherwise they'll fall off schedule. The teams adapt their workflow on a daily basis. Every delay is carefully logged.
Each morning or a day before, normally we schedule what work needs to be done, and every job has its job card number and task related to it.
Each page describes one of the 10,000 job cards in total, from a simple cleaning job to a repair that affects the plane's safety. Like the inspection of the engine hoisting, for instance. It attaches the turbine to the wing. Any problem could spell catastrophic consequences. Andre is replacing a very specific bearing. This is also a mandatory process in the IL check.
It takes all the loads, literally. It transfers the loads through the pylon, engine, pylon, and wing structure. And this is the job of this bearing. We use this tool when the bearing is literally stuck. It's so hard, there's so much torque in it. You will never loosen it.
Andre has to drill into the bearing's mount to replace it.
The material is so strong that the bits wear out quite easily.
The connection is incredibly strong. The ring is mounted to the wing. The entire engine's 6-ton weight will later hang off this single tiny component. This connection must never break, no matter how strong the wind, turbulence, or vibrations.
Finally, yeah? This little thing is what holds everything together. It keeps engines flying. Yeah, it's a bastard.
Meanwhile, on top of the wing, the cabin team still has a problem with one of the monuments. Cabin boss James and his team have dismantled aircraft from all over the world. When you're dealing with so many different components, it's impossible to know every detail. Take these plastic bumpers, for instance.
Sometimes you forget about these things. It's a small item that sometimes the manual does not tell you to remove that bumper, but to get out from the door, it's really exact height. So it's just a few millimeters.
Finally, the module fits through the door and is now on its way for repairs in the neighboring shop. The team has nearly finished dismantling the cabin. Next step, finding the defects.
It's getting a bit exhausting for everyone, but this is the phase when you need to be fully concentrated, because any mistake at this stage can jeopardize the T-80.
DOD, that's the planned date of delivery for the repaired plane. In 33 days. So far, the team has been right on schedule. The cabin is empty. The structures team now inspects the ceiling, walls, and floor for damage. Biggest risk in the interior? Moisture, and the resulting threat of corrosion. Outside, the team is facing their most challenging dismantling task. One of the flap track bearings is faulty. This calls for some heavy machinery, After all, the flap alone is over 5 meters long and weighs 300 kilograms. Engineer Andres Pateri is responsible for this job.
The hardest part is not to take it out, is to make sure we keep it clear away from the aircraft and not to damage or not to hurt anyone.
These huge components influence the airflow to make the plane ascend, descend, or maintain its course. During takeoff, the flaps boost lift. For landing, they increase air resistance. During the inspection, they demand Andre and his team's full attention.
More. Go. Stretch. Okay. Yeah.
The crane has been calibrated precisely to the weight of the flap.
What we're doing now is we're adjusting the hoist so we can have it centered. So when we actually remove and take the weight of the flap, we don't have any surprises, like all the weight goes in the aircraft or moves suddenly out and throws us out of the docking. I think it's enough, huh? That's tight, Ruben.
The center of gravity must be exactly in the middle. Otherwise, the landing flap could suddenly tip over.
Oh, should be good. Thank you.
The cables are taut. Andre releases the flap from the wing.
Slowly. Okay. Just leave it like that. Okay. Oh. It's moving. Okay, it's coming out. It's coming out. By hand. Oh. Okay.
Now, the flap is held only by the crane. A dangerous balancing act.
We need to push up and Johnny, pull it.
The biggest risk? That the flap could hit the fuselage and cause millions worth of damage.
Rope. Oh, rope.
Oh,
All right.
be careful of the docking at the back.
Suddenly, the giant part threatens to slip. While some members of the team focus on the big parts during this mega pit stop, others take care of the tiny details. Shaya Ray Kalea from the structures team checks everything that holds the Airbus together. For example, thousands of screws. This is just one of the many jobs that are invisible to passengers, but essential to their safety during a flight.
That responsibility is big because I will just think if my family is riding that plane, I have to make sure that it's safe.
The screws are the smallest components in the aircraft, but they are also the most common. It is cheaper to clean and repair each individual screw than it is to just replace them all. Shaya also repairs the metallic components in the cabin and is one of only 5 women working in the entire hangar.
What I like most about my job is that I am being challenged every day. I am challenged to do my best and push my limit.
Shaya's job? To repair Kilo Romeo's shell. During a flight, it's what protects passengers from temperatures of minus 50 degrees outside the plane. Shaya has been fascinated by flying since she was a child. As a woman working in a male-dominated environment, she also sees herself as something of a pioneer.
Don't be afraid to get your hands dirty. Don't be afraid to be one of the boys, and don't be afraid to conquer the men's world. Because if they can do it, why can't we?
Outside the cabin, Andre's team is still struggling with the 300-kilo landing flap.
Jib up, go.
The workers have to lift the flap up and pull it away from the plane at the same time.
More, more. Hand over the rope. Watch the harnesses, watch the harnesses.
They've done it. This final component marks the end of the dismantling phase.
Luckily it's out. Happily out. Yeah, job done for today.
Day 19 of the mega pit stop in Malta. The 5 departments of cabin, engines, cargo hold, electronics, and structures work at different paces. The engines team is completing its repairs. The turbines have been checked, repaired, and signed off. The cabin team has removed and numbered all of the parts. Next step, start repairs in the seat shop. For 238 seats, this means 15 days of work. The seat rows are set up exactly as they are in the cabin. Every seat has its assigned place, as the customer expects the plane to be essentially the same as before the pit stop, except that it's been overhauled. Jason starts by taking inventory.
We will check, first of all, the cushions that are in good condition, or if any are damaged or worn, we will need to replace. Then we will start checking functional of the seat.
An assessment of the basic frame and seat belts are mandatory jobs for this check interval. What's more, the airline has opted to have the seats fully reconditioned to make sure its passengers are comfortable.
What's the condition of the cushions?
Cushions, some have some damages. They're worn. And regarding the bottom covers, we've got about 60 stained.
The team cleans and repairs anything worth saving. For larger scale damage, Jason orders specific spare parts. When dealing with so many different airlines, keeping every spare part in stock for every aircraft model is impossible. The new landing flap has arrived at the hangar. Unfortunately, it's the wrong color for the airline. Solution? Paint it over. This means a delay to the schedule.
It puts more pressure on us to deliver the actual milestone on time. So we delayed it maybe like 2 days, the installation, since it was originally planned.
A 2-day delay. It's a major setback for the hangar crew. After all, the next flight has already been scheduled for Kilo Romeo. The shop team tries to win back some of the time lost. 102 specialists polish the components to return their original shine. They do this for every part that passengers come into contact with, including the wall panels, windows, ceiling lights, and toilets. If properly maintained, this Airbus is able to complete over 80,000 flight hours. There's just a week to go before the plane is delivered to the airline. While the cabin team is well underway with repairs, the hangar crew is still looking for faults.
We kick into the inspection phase, where all inspections are carried out throughout the aircraft, and any defects are identified, parts ordered, and items need to be rectified, basically.
Current status: the engines are still in very good condition after 6 years. However, there is still one dangerous job left to do: cleaning and checking the fuel tank, a job that risks suffocation or explosion. And the electricians still need to check mile upon mile of cabling. The fuel tanks are located in the wings and at the bottom of the fuselage. If they contain any foreign bodies, these could rub against the tank and cause corrosion. And corrosion could cause fuel loss. Cleaning is therefore a hugely important job, but unfortunately not a particularly safe one.
This is the vacuum pump that works with air, because obviously you cannot work with electricity in the fuel tank.
Well, so basically, Piney, I'm going in to do an inspection, all right? So let's do this.
The area that Ruben is climbing into is normally filled to the top with fuel. That's over 200,000 liters. Fumes, darkness, cramped conditions. You have to be a special person to take on this kind of job.
It's not fair. I'm planning to get fat, you know, because it's not fair. It's always me, you know.
You have to get fat.
It's not nice being the skinny guy inside the engines.
You have to get fat and get old.
Yeah. So yeah, I have to inspect everything, every corner, every rivet, every high lock, everything, correct assembly, because the fuel tank is quite critical. So yeah, I have to make sure it's as clean as possible. Chris.
Yes?
I'm moving on to the inner tank. Can you please hand me the vacuum, please?
Coming.
Ruben is also on the lookout for cracks and leaks. It doesn't take long for such defects to expand. The mechanic has to inspect a total of 6 fuel tanks, the smallest of which is just 30 centimeters tall. One thing Ruben always has with him on board: a strange feeling in his stomach.
I find it quite scary, to be honest, because, yeah, if something happens.
It could be that there are fumes. He could trip. He could slip. And then, obviously, he will need help. If he's by himself, no one can help him. But if there's a colleague outside, he can either call for help or go in and help him. The worst thing to do is to actually panic. Ruben, is everything okay?
Yep, everything good.
Okay.
And then, suddenly, Ruben finds a problem.
These little tiny metal shavings could cause a problem everywhere in the aircraft, because they could be a potential for corrosion, and we don't want corrosion on an aircraft.
Ruben soaks up the splitters with his vacuum pump. In total, he needs 2 days for inspecting and cleaning all of the tanks, completely in the dark. At the same time, one story up. Cabin boss James is right on schedule. His team has finished checking the interior. Now it's time for everything to go back in. There's just one team still working on the inspection phase. The electrics team, which has to check 400 kilometers of cable. They all come together in the avionics bay, Kilo Romeo's control center. It is located directly under the pilot seat. This is where it all comes together: entertainment systems, smoke detectors, autopilot. Declan de Jong checks each and every connection, a job that requires total concentration.
You have to be alert all the time. You have to watch what you're doing so you don't trip and bump your head or fall or break anything.
Declan performs the first of 3 checks. 2 more electricians will then come along behind. This is because job cards directly related to passenger safety are always checked by more than one expert.
And it's basically checking all the wires for damages, for burning marks, shaving, and that kind of stuff. So like this wire see it's a bit loose all the way. So first we do is clean with the brush and some alcohol, make it clean.
Loose wires vibrate during the flight and could generate friction, a safety risk that shouldn't be underestimated.
Now what could happen, say if there was like a cable broken or damaged and it could make like sparks, it would give in the cockpit an indication that there's a fault somewhere. And maybe in the worst case scenario, it could spark and cause smoke or fire. Worst case scenario.
The last few days of the mega pit stop. Daryl's team now has to put the plane back together again as quickly as possible.
We're hitting the final phase, milestones all on track, and we've got 374 defects still open. You're doing a brilliant job. Keep focused and come on, let's do it, okay? Let's go.
Back at Jason's seat shop, the new seats have arrived.
New seats. Smells good, eh? It's like when you buy a new car.
Jason is installing 16 brand new seats. The rest have been reconditioned. The seating is arranged right down to the last centimeter. The issue here is one that passengers take very seriously: legroom. The rows can't be too close together, nor can they be too far apart. If just one row is in the wrong place, this can trigger a chain reaction. It could end up that a whole row of seats doesn't fit into the plane anymore.
You have to move everything, all seats or cables. Hopefully, it doesn't happen.
There's another problem. The paneling is still missing in some areas. For Jason and his seats, that means stop. Project manager Daryl is tense. During the installation phase in particular, it is essential to make sure all teams are perfectly in sync. Otherwise, his team may miss the upcoming deadline.
At the moment, although it's a bit quiet, teams are a bit frustrated to a certain extent that we could be in a better situation than we currently are.
Everything is happening at once in the cabin. The paneling is finished, the seats are going in, and the bulky monuments have to go back in too.
Slowly, guys. Oh. You need to go forward. Raise. Lower. You're right.
Even the smallest scratch means remove the element again, repair the defect, then reinstall.
Okay. More up, yeah. More up, yeah. All right. More up.
Now it's time to see whether James can deliver on time.
To reach the target, you need to be concentrated fully on the project. Sometimes, if you make a wrong decision, like you install something before another one, you might end up removing it.
A huge puzzle made up of millions and millions of pieces. Every piece has been checked for safety and repaired. From the tiniest screw right through to the skin, slowly but surely, Kilo Romeo gets its outer shell back. Shia Ray and the structures team are making up for lost time.
Now that we're on the installation facing already, it's very fulfilling because that means we did the job fine, yeah.
It's a precision landing for head engineer Andre, too.
It's like your house, you know? You're always here, coming to work, making sure it's safe to fly, fitting everything in place like a puzzle. Yeah, and at the end, it's just satisfying just to see it go.
Last problem area to address, the cabin. But things have finally started moving here too. The monuments and seats are all back in position.
Yeah, it's satisfaction after all that work, you know, removal, inspections, rectifications on seat, bring them like as new again.
Day 39. Kilo Romeo looks brand new, both outside and inside. Project manager Daryl has done it, and 1 day ahead of schedule. The airline's inspectors will perform one last check of the entire aircraft before the Airbus A330 can take a test flight. The plane can't start transporting passengers again until these 2 steps are out of the way. 10,000 job cards, 25,000 man-hours. Kilo Romeo is back and ready to start safely transporting thousands of passengers to their destinations.
Very exhausted. Very exhausted. But again, this is the most rewarding day when we see the project coming to an end. A satisfied customer, which is important, and most importantly, a well-maintained aircraft with a high level of quality for the safety of our passengers.
For Daryl, the next project is already waiting in the wings. He and his 170-person team are the unsung heroes of aviation. The crew here in Malta makes sure that air travel remains the safest mode of transportation. What does it take to cut a ship into 2 halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. It is one of the fastest and most state-of-the-art trains in the world, the Russian Sapsan, in English, Peregrine Falcon. The base model of a Sapsan consists of 10 cars, offering space for up to 604 passengers. Its maximum speed, 250 kilometers an hour. Its technology is perfectly adapted to the Russian climate. Even at minus 40 degrees Celsius, all systems function without fail. One of a kind, a Peregrine Falcon is also capable of double heading, which means it can pull 20 cars. taking it to a proud length of 500 meters, the record for the longest high-speed train in the world. After 3.7 million kilometers, every Sapsan needs a mega pit stop. During what's called a R3 revision, engineers overhaul the entire train. To accomplish this within the 34 days they've been given, they have to separate it into two halves and work in parallel at two different stations. The most complex of all the processes involves lifting the train and removing and replacing the chassis. While this is going on, the other half of the train is repainted. They also have to replace the pantographs and overhaul the onboard electronics. Inside, all 604 seats will be checked and repaired. They will only be able to meet the delivery deadline if everything goes according to schedule. St. Petersburg, Russia, Metallostroy train depot. This workshop was built especially for maintaining the Sapsan. Dennis Sharamet is the project manager for the upcoming mega pit stop.
Now it's getting tense. The train is arriving soon. A major revision is comprised of many different work steps, from cleaning to inspection. But the first important thing is running it in. That's when it all starts.
The Sapsan trains have been in operation since 2009. Today, the first train will arrive at the depot for the big R3 revision.
While running it in, it is very important to watch how the wheels rotate and how the bogies and fans are working. We can tell if there are any problems just by listening to it.
Damage that previously went undetected, and that, in the worst-case scenario, could seriously disrupt the tight schedule.
Here I can already see the first problems. Several windows are broken, probably from rocks that the train threw up while running.
A total of 10 windows are shattered. That means a whole day's worth of unscheduled work. Once the train is in position, the technicians start by disconnecting it from the overhead power line. Working with 3,000 volts would be too dangerous. Instead, they connect it to the power grid in the hangar. The clock is running now. The train is scheduled to be transporting passengers again in just 34 days. Project manager Dennis Sharamet is also on the lookout for internal problems. The onboard computer stores and reports technical errors, but not broken shelves, seats, or tables.
Now I'm checking the seats. They need to be easy to adjust.
Travelers can book the Sapsan in a total of 6 different classes. They can choose between Economy Class, Economy Plus, Dining Car including food, Business Class, and Premium Seat Class. A trip from St. Petersburg to Moscow costs between 60 and 280 euros. One highlight is the conference lounge in car number 1. Price about 500 euros. For that, you get a sofa, comfortable seats with tables, 3 of your own televisions, and dimmable lighting. So far, everything looks good. The only things worrying the project manager are the broken windows.
What's complicated is that the glass is glued in with a special material. To replace the window, you have to cut it out, clean it, prepare it, apply primer, put adhesive on it, and only then you can insert a new one.
While Dennis Sharamet continues his patrol, some 20 workers outside converge on the train and begin the dismantling process. They also clean the water tanks using a citric acid solution. The acid disinfects and decalcifies the tanks. Inside, work is already in full swing as well, just 1 hour after the train's arrival. The vacuum toilets are all removed. A workshop will completely overhaul them before workers reinstall them in the train. The kitchen is also on the agenda for the first day. If any of the appliances are broken, there will still be enough time to repair or replace them. Dennis Sharamet's team works through almost the entire night to make sure that they can divide the train tomorrow as planned. Day 2 of the mega pit stop. The 250-meter-long train will be split today, a premiere, because this Sapsan is the first train to ever need an R3 revision.
You have to take them both out. Everything's on schedule. We're preparing to divide the train. To do this, we will remove the cables and take out the bellow where the cars are connected.
Since the Sapsan has underfloor engines, several cable harnesses run under and between the cars. They are responsible for controlling the engines and brakes. Only once the technicians have detached these cables can they separate the train. Because the train is disconnected from the overhead line, a diesel locomotive is needed to shunt the 600-ton Sapsan. It pushes the entire train to the paint shop. Here, it is divided into 2 parts. The second half is taken to a track with a special lifting system. Project manager Dennis Sharamet has scheduled 1 hour for the shunting work. Everything is going according to plan for now. The train is in the paint shop. To divide it, workers first remove the bellow. The coupling is next.
A nut is causing problems. It won't budge.
This Sapsan has been in operation for 9 years. Today, it's going to be divided for the first time. The problem is that rust and dirt have jammed the screw connection on the coupling, making it impossible to loosen. It is the first big challenge for Dennis Sharamet. His team can't carry on with their work until the train is divided. The super tight schedule is under threat.
If we move it now, it should come apart.
They got it. But thanks to the complications, the team has lost valuable time. The painters get right to work. Meanwhile, the diesel locomotive pushes the other half to the adjacent track. Here, there are special jacks that can lift the entire train half at once. The shunting work is complete by the early afternoon.
Да, сейчас все, слава богу, нормально.
I'm glad we're done with that. Fortunately, I planned in a bit of buffer, but I hope that kind of thing doesn't happen again.
Next step, replace the bogies. For this, the engineers have to lift the train half, all 125 meters and 340 tons of it. A critical moment. All 20 jacks have to be completely in sync with one another. Just 2 centimeters difference and the train could tip over. Only once the cars are at a height of 2 meters can the workers move the old bogies away and place the new ones underneath. Traveling at speeds of up to 250 kilometers an hour, the train is subjected to an incredible level of force. The bolts connecting the bogie and car body are 30 centimeters long and 3 centimeters thick. Workers now have to remove 10 of these bolts on each bogie. Workshop foreman Viktor Lipov is responsible for the lifting process. He meticulously controls the work of his mechanics. And he's highly aware of all the sensitive technology installed around the bogies. To save space in the cars, all mechanical and electrical components, such as transformers, compressors, and power converters, are installed under the car bodies. This leaves more space for seats in Sapsan trains.
If we forget a screw, it's very bad. It could cause things to break down, which could cost a lot of money.
Although the schedule is tight, the experienced workshop manager has plenty of time for the inspection. If anything goes wrong, he's the one responsible.
I've checked everything now. We can lift the train.
Lifting is handled by 20 jacks, each with a maximum capacity of 20 tons. The workers position them at special points under the car bodies.
If the jacks are not positioned precisely, the train could tip over and fall down, which is why we have to make sure the jacks are seated exactly.
Also important, all 20 jacks have to be completely in sync. They are connected by data cables and can be centrally controlled.
We're ready. Let's get started. Arthur, go to that bogie over there.
Even though the system is electronically controlled, Viktor positions one worker at each jack. Better safe than sorry.
I'm a little nervous, but that's the way it has to be. I use it to control the jacks. Ready? Pasha? Everything okay?
In the first step, Viktor lifts the train just a few centimeters. Then, his people check it again. There's a problem at the rear bogie.
The cross member won't come off.
I think we just need to go a little higher.
It has already come loose a little bit.
Look at the beam here, Pasha.
I'm going up another 3 centimeters.
Victor's plan? Keep lifting the train up very carefully and hope that the jammed cross member will come loose on its own. And indeed, his plan works.
Sometimes parts get rusty and seize up, and this creates problems. Fortunately, everything is working again now. But I'm still going to take another look.
Now, Victor can lift the train to the final position. It takes him about 20 minutes to get it to a height of 2 meters.
We're done.
Now comes the next step, replacing the bogies. Viktor Lipov and his team pushed the bogies out from under the train by hand. Despite their impressive weight of 11.2 tons, this is still the fastest method. Each bogie has covered approximately 1.2 million kilometers, equivalent to 30 orbits around the Earth. Most of it in freezing temperatures and snow, an extreme strain. Time for a general overhaul. In the paint shop next door, work is being carried out on the other half of the train. Kicked up stones and ice chunks have left countless dents in the Sapsan's aluminum skin. Workers will have to repair them first. They can't repaint the train until this work has been completed. The old bogies have since arrived in the workshop at the other end of the depot. Boss Mikhail Dubov and his team are responsible for the regular exchange of the Sapsan's bogies.
The brake shoes in particular have to be measured over and over again. We check them at every inspection and replace them when needed. The rubber parts suffer the most damage. They almost always have cuts or indentations, usually caused by chunks of ice in the winter.
Mikhail and his team check these wearing parts at every basic inspection and replace them as required. For the major R3 revision, they take the bogie apart completely. They start with the crossbeam on which the car body sits. The main part of one bogie, the frame, weighs almost 10 tons alone. Mikhail and his workers check the steel for cracks. They replace parts such as springs, brakes, dampers, stabilizers, and all screws, whether damaged or not.
The bogies hold the weight of the entire train. If something breaks or falls off, that's bad, and it can cause an accident. That's why we have to check this part very carefully and always replace the parts according to the maintenance schedule. In other words, before they can break.
It takes about a week for a bogie to be overhauled and reassembled. The wheel sets are sent to a different workshop. The stress on the wheels is particularly high when the train is in motion, especially on the running surfaces and the wheel flange, that is the raised side part that prevents the wheel from slipping off the rail. A special lathe brings the wheels back into shape. The lathe has to machine down about 4 millimeters of specially hardened steel to get rid of any unevenness and corrosion. The wheels still have to be put on the test bench. After that, they can be reinstalled. The maintenance team has an exchange system in place for the bogies. 10 fresh bogies are ready and waiting for the presently wheelless Sapsan. After the overhaul, they'll use the newly removed ones for the next train. A time saving, to be sure.
It all looks good. Everything's okay.
The workers push the bogies under the train in a specific order. Workshop foreman Victor checks that each one ends up in the right place.
Every bogie has to be in a certain place. The cars have different axle loads, and therefore each bogie is calibrated differently. We're not allowed to swap them under any circumstances.
Some bogies have a motor, thus known as motor bogies. The ones without are called trailing bogies. This also plays an important role in distribution. By late afternoon, the work is complete. Next, the technicians reconnect the cars to the bogies. The greatest difficulty? The connecting bolts are located on the crossbeams, which have to be fitted precisely into the carriage frame, right down to the millimeter. This is why they initially lower the train to just above the bogies. With the aid of integrated air suspension, the bogies are pumped upwards for the last bit, where they engage. It's a complicated step, during which a lot can go wrong.
Everything looks good. So far, there have been no problems in the preparations for lowering. Now the workers are about to move into their positions, and then we can begin.
After the final preparations have been completed, workshop foreman Victor Lipov instructs his workers.
If there are any problems, don't call me first. First, press the emergency button and then call me. Is that clear? Great, then let's do it.
As with lifting, Victor Lipov positions one worker at each jack. Once again, the rule is to keep an eye on the car body and bogie and hit the emergency stop immediately if there are any problems.
Pasha, everything okay? I'm going ahead.
The first 1.5 meters go quickly. Then it gets tricky. The workshop foreman feels his way forward, millimeter by millimeter. If the connecting bolt does not slide exactly into the hole, it could get stuck. In the worst case, the team's only choice would be to destroy the bolt to release it again. Just before the bolts engage completely, Victor stops the jacks. Now, manual work is required for the final millimeters. The workers push each bolt individually into the corresponding hole. To do this, they pump up the air suspension on the bogies. They also lift each bogie with a wooden beam. It's a simple and effective method, but for this last step, it needs not just strength, but above all, feeling. Not possible with a machine.
That was the 10 millimeters we needed.
With this approach, the workers engage one bogie after the other.
It worked out well.
The paint shop is also making good progress. The workers are priming the last car from the other half of the train. Then they paint it and apply 2 coats of lacquer, a total of about 140 kilos of paint on each car. Day 15 of the mega pit stop. Around about the halfway mark, the first part of the train is almost finished. You can no longer tell that it's already traveled 3.7 million kilometers.
The paint work on this half is finished. They've done a good job. Now we can swap the 2 halves of the train. Right now we're still on schedule, which is really important to us. Despite the minor difficulties, we're halfway finished with the overhaul. But we still only have about 20 days until we have to return the train to the railway company.
The project manager now orders the train halves to be switched. The freshly painted section is placed on the jack track. The train half with the new bogies goes to the paint shop. The diesel locomotive is once again responsible for reparking. Dispatcher Alexander Filipov coordinates the shunting work.
The train has been stationary for more than 2 weeks now. It's possible that not everything will work right away, so we have to check everything again.
And they have to listen very carefully. The downtime during the mega pit stop could have caused the brakes or axles to become stuck. A squeak or rattling would immediately indicate to the specialist that something is wrong.
As we can hear, it is not making any strange noises when rolling.
The shunting work may seem cumbersome, but if you first painted the entire train and then replaced the bogies, the revision would take about 3 weeks longer. The train half with the new bogies now comes to the paint shop. After 30 minutes, it's in position.
The maneuvering went as planned. There were no problems. We're going to start painting right away.
The painters don't waste any time. They only have 3 days for each car for sanding, filling, priming, painting, and applying 2 coats of lacquer. At the same time, Viktor Lipov and his workers replace the bogies on the other half. The team works practically around the clock. Even after the exchange, there are still only 12 days left for all the work that has to be done. Day 31 of the mega pit stop. In 4 days, the team has to return the train to the railway company. In the meantime, the Sapsan has been completely painted and the 2 halves have been coupled together again. But the work is far from finished. Now it's time for the pantographs on the roof. Above all, the so-called grinding strips are extremely susceptible to wear. They are made of soft copper with a graphite core. Friction on the catenary causes them to constantly wear down. At speeds of up to 250 kilometers an hour, the pantographs are also subjected to severe air turbulence. In the course of the major R3 revision, the team replaces them completely. The Sapsan has a total of 4 pantographs. They all clearly exhibit the wear resulting from the many kilometers and the Russian climate. That is why the workers replace them all together. Each pantograph weighs 270 kilograms. The freshly serviced spare parts are ready and waiting. Also here, the system of exchange is the only way of meeting the tight maintenance schedule. While traveling, 3,000 volts flow into the train through the pantographs. Just one poor seal could lead to a short circuit and paralyze the train.
Accuracy is very important in this work, because without pantographs, the train cannot move. The old pantographs now come into the workshop where we check and repair them, and then we install them on the next train.
In addition, the workers replace all cables and insulators. While the work on the outside of the train is almost finished, there's still a lot to be done on the inside. Only 2.5 days left. Then the Sapsan has to be ready for service again.
We've just checked the progress of the work, and at the moment, everything is going as planned. But there is not much time left, and there is still a lot of important work to be done. For example, we still have to check all the technical systems. I hope we have time to do it all.
And there are other jobs still to be done. The team has to replace the broken windows and check all 604 seats on the Sapsan, and if necessary, repair them, as well as servicing the 2 drivers' cabs and checking the interior doors and electrical systems. Train technician Alexei Zaloshenkev is responsible for the broken windows. All the windows on the Sapsan are almost 4 centimeters thick. They are made of 2 panes of laminated glass, which makes them extremely safe. Even large flying stones can't get through.
These windows are different from the normal windows you're familiar with. And the frame is made of aluminum, which is why it's so hard to move.
What's more, the windows are fixed with an extra strong adhesive. It takes Alexei almost an hour to cut out the double pane. And he still has 9 more broken windows to deal with.
To get it out of the train, you have to hit it here, and the middle falls out and the edge stays in. That's why it splinters like this.
To remove the tension from the glass, Alexei smashes the window. This makes it easier to lift out. While Alexei's still struggling with the window, electrical technician Anton Smirnov is checking the fire alarm on the Sapsan. A special test spray simulates smoke,
Now I'm waiting to see if the alarm reacts. This bit is lighting up red. That means the fire alarm is working.
Each electrical cabinet in the train is equipped with at least one fire detector. This is where the danger of an unnoticed fire is most threatening. A total of 110 fire detectors are installed inside the Sapsan. To avoid panic, no alarm can be heard in the cars themselves.
This is the room for the conductor and the engineer. The fire alarms can only be heard in here. Here we can see there's a fire alarm in the passenger area. If there's ever a real emergency, the team can react immediately.
All fire alarms are working. Anton now heads to the seats in first class, together with a colleague. The adjustable luxury seats are full of all kinds of electronics.
Sometimes passengers accidentally pour coffee on this bit here, and the liquid causes the electronics to burn up. This is a major problem for us.
Anton and his colleague check all 104 electronically adjustable seats and repair them if necessary. All that in only 3 hours. Another team of technicians is working on the train's 22 automatic doors. The main focus of technician Igor Yarinov is the door's emergency stop.
I'm looking at the emergency switch. This rubber piece is there to make sure no one gets hurt. I'm checking if it works. And at the same time looking at the door mechanism.
Igor recalibrates the sensor on every door. Anton is now finished with the seats. Now he'll tackle the 2 drivers' cabs.
The first time I sat here, I thought it was pretty exciting.
The Sapsan's driver's cab is one of the most modern in the world. The onboard computer monitors all components on the train with the aid of sensors.
Now I'm erasing the fault memory. The work we've been doing has caused many malfunctions to be triggered. The computer controls the train and checks whether the faults have been corrected. Everything's all right here. Now I just have to do a few little things and then we're done.
On the outside of the train, technician Alexei and his colleagues prepare to install the new windows. The special adhesive is UV resistant and transforms into an extremely durable rubber mass while drying. A Sapsan window weighs about 20 kilos.
Now the window has to dry for 24 hours. Then I can do the outer seals. We do all the other windows the same way.
The train has to be back in service in just 2 days. While the final work is being finished off, the train crew is also completing all the preparations for the passengers. Mega pit stop, day 33. Today, the final technical tests are taking place. For the train to travel quietly and above all safely, Viktor Lipov has to adjust the bogies to millimeter precision.
We've fine-tuned the train's bogies. Now, I have to make sure everything is correct.
For this, the train travels with each bogie individually on a special scale. It measures the wheel load on both sides. Only minimal deviations are permitted.
If I find a mistake now, we'll have to readjust everything. Stop! 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 And we'll probably have to postpone the test drive so we can correct the error beforehand.
That would be a major setback. The fact remains that the train is supposed to be in service the day after tomorrow.
We're done now. Everything's fine. The train is free to roll.
But there's one last milestone that's still missing, the test drive. The train is not allowed to take on any passengers until the test is complete, and it starts at 3 o'clock in the morning. Dennis Sheramet and his team can only know if they have done a good job when the train passes the test drive. Have they successfully mastered the first major R3 revision of a Sapsan? The test driver has had special training. Ultimately, he helps decide whether the train is allowed to return to active service or not. Test drive takes 6 hours. During this time, the Sapsan has to cover around 500 kilometers and perform various braking and driving maneuvers.
We have a test program, and we're working through it now. We've completely dismantled the train, and now we have to check whether everything is working properly.
After 34 days and 5,350 hours of work, the Sapsan rolls back onto the rails for the first time. On the open track, the first test, emergency braking. While traveling at 200 kilometers per hour, it has to stop within 1,600 meters.
Fantastic. Excellent.
Emergency braking worked without any problems. Next, Dennis and Viktor check the bogies from the outside. For this, the train drives past them very slowly.
There can't be any noise, crunching, whistling, or squeaking while the train is moving.
If Dennis or Viktor were to hear anything, it would be back to the workshop for the train. Indeed, the freshly serviced Sapsan passes this test as well.
Okay, let's go.
Let them know we're on board.
Sapsan drivers.
Sapsan 5, go ahead.
We're on board.
Okay, then we'll go up to the platform.
Now we will walk through the cars and listen again.
At full speed, Dennis and his team listen out for any strange noises inside the train.
I pay special attention to what the wheels sound like. You shouldn't hear anything but the sound of rolling. Then it's fine. If there are any other noises, it means we have a problem.
The train driver guides the Sapsan along the track at 200 kilometers an hour. Behind him, controllers continue their work.
Все хорошо.
Everything is fine.
Даже те звуковые
Even the sound I heard at the beginning in the 6th car is no longer there.
в вагоне в начале поездки сейчас уже практически отсутствуют.
That tells us it was most probably just the new wheels.
Вопрос был в обточке колесной пары.
They got it. Dennis Sharamet and his team have successfully mastered the very first R3 revision of a Sapsan. Now, the world's longest high-speed train is ready for the next passengers. In just a few hours, it will once again be transporting hundreds of them, with high speed from St. Petersburg to Moscow, until the next mega pit stop. What does it take to cut a ship into two halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. It is one of the most state-of-the-art fighter jets in the world, the Saab JAS-39, known as the Gripen, or in English, Griffin. So what is the Swedish-built jet used for? Pursuit, attack, and reconnaissance. The 35 million euro fighter jet can fly at double the speed of sound and is renowned for its high level of reliability and versatility. It can master both the extreme cold and difficult runways. To avoid deadly accidents, every jet has to pass a mega pit stop after 200 flying hours. The machinists put the Gripen to the acid test. They check the hydraulic system, all moving parts, and the oil, the aircraft's blood. The ejection seat, the pilot's life insurance. The access panel, the skin. The biggest part is the engine check. The turbine is the heart of the Gripen. They also overhaul the weapon system, the fist. All of this in only 8 weeks. The Czech Republic, the 21st Tactical Air Force Base in Čáslav, 100 kilometers east of Prague. Home to 14 Gripens. 2 of them are on call 24/7, ready to defend NATO's airspace. The fighter jet with serial number 39.238 already has 1,800 flying hours under its belt. Time for a major mega pit stop. Head mechanic Martin Batra will be inspecting every inch of the plane with a fine-tooth comb. Any fault could put airspace safety at risk.
I have been interested in planes ever since I was little. For me, the most fascinating thing is that such heavy machines are able to lift up into the air and fly. And I am in awe of the fact that you can master these planes up there whenever you want. Sadly, I wasn't able to become a pilot myself, as my hearing and sight weren't good enough. That's why I became a mechanic. It's a great job. Nowadays, every aircraft is different. Planes start to age and often reveal problems that we knew nothing about. For us, that's the biggest challenge during this pit stop.
Martin's team has to be finished in 40 working days. As well as complete precision, this also means a whole lot of time pressure. His crew starts right away. The worker's first job is to take a sample of the hydraulic oil. Admittedly, it is a pretty small task, but sending it off for analysis in Sweden, a few hundred kilometers north of here, can take several weeks. And changing 20 liters of fighter jet oil requires a lot of time and effort, too.
We will start the engine for 30 minutes so that we get all particles to move. We will first take the hydraulic samples, then we'll do the IP gravity spreadsheet. And after the shutdown, we will take the engine samples.
Aircraft mechanic Roman Brazda starts up the plane and moves all of its wings to make sure the oil is distributed as evenly as possible throughout the plane. Then, Martin siphons off the oil. Now, all that's left is to hope that the result is positive, so they don't have to replace the oil. After all, this mission has more important priorities.
We have 14 aircraft stationed here. Altogether, they have to fly 2,000 hours in 1 year. A huge challenge we face is keeping the window for maintenance work as small as possible so that the planes can complete their flying hours. That's why we work around the clock.
Incidentally, the teams give every fighter jet a nickname, depending on its weakness. The Beast is undergoing a mega pit stop today. Its name comes from the fact that its combustion system keeps developing a life of its own. First things first, it's time to give the Beast a good wash.
We're preparing the plane for cleaning. Because we use a high-pressure cleaner, there are places where water could get into the plane. That's why we have to tape up any points that aren't completely leak-proof, including the cabin. Rust is the worst thing that can happen to a plane.
Cleaning is about more than just making sure the plane looks nice. It is the only way the team is able to locate any damage to the fighter jet's outer shell.
Here is something small. Chipping paint is a reoccurring problem. After all, the planes are a good 14 or 15 years old. As long as we can see the silver layer, then everything is still okay. This protects the pilots from lightning. If the silver layer disappears, there will be problems during a storm. The systems could shut down if a bolt hits the plane.
The access panel is a kind of harness to the aircraft. Under the special varnish, there is a rust and lightning protection. The mechanics inspect the access panel precisely. Every single scratch has to be repaired. If they find larger damages, they even replace parts.
Yes, that'll be fine. I'll pass the washer jet up to you.
First, the Czech Army uses a special mixture to remove any larger bits of filth. Then, all the team has to do is spray down the film of dirt.
We're not quite done yet. There's still work left to do.
It's almost like a car wash, just a little more hardcore than removing a few flies from the windshield.
Most of the dirt is fuel, insects, engine oil, hydraulic oil, and fine particles. Because the jet is up in the air, it also gets covered in lots of dust particles, sand from the Sahara, and animals. That's why we use stronger chemicals than in a car wash. The jet's paintwork is a lot tougher than the paint used on cars.
Day 2. Now the team turns their attention to the ejector seat, every pilot's life insurance policy.
Stop!
Including the parachute, rocket propeller, and emergency kit, The seat weighs 120 kilograms. Over the next 15 days, it will be completely dismantled, serviced, and put back together again. This also includes a functional check and test of the pyrotechnics. The man in charge of making sure everything works when the jet's back on duty, aircraft mechanic Peter Sikora.
Even the ejector seat has to be checked on a regular basis, because all materials age. We check all the seals regularly and replace anything that isn't up to standard. The same goes for the individual pyrotechnic cartridges. They age too, so of course they have to be replaced. Same for the belts, springs, and so on.
Peter isn't daunted by this responsibility. However, he doesn't quite take the same stance when it comes to the explosives themselves.
I don't feel under pressure. After all, there's plenty of equipment in the aircraft to make sure the pilot stays safe. It's more the explosives that worry me, because they are a risk to me.
But it is precisely this highly explosive substance that allows the seat to work in the first place. It triggers a range of emergency measures, from launching the seat to releasing the parachute. But one thing at a time. Before the mega pit stop mechanics can dismantle the seat, they have to remove the volatile explosives. There is even a special ejector seat workshop to assist. Here, the mechanics remove the 9 pyrotechnic cartridges in total. These cartridges hold a total of 3.5 kilos of explosives and accelerate the pilot to 17 times his own body weight in an emergency. So, beware. Day 4 in the mega pit stop. Now it's time to look at the fighter jet's power source. The mechanic starts screening the turbines, and that's no easy task. Including the afterburners. The engine can produce thrust of over 80 kilonewton. An Airbus A380, which weighs more than 80 times as much, achieves just 4 times this force. The turbine is the heart of the Gripen. Little scratches can have severe consequences. If the engine collapses, the aircraft is crashing down. In case there are damages invisible to the naked eye, the mechanics inspect everything precisely with the stethoscope. If they discover one mistake, the whole engine has to be replaced. The time has come for Roman Basta. Wearing a special anti-static suit, he climbs inside the fighter jet's inner chamber.
This is a job that most people don't like doing because you have to climb all the way inside this very tight space. People with claustrophobia would never be able to do this job. But for me, it's the best experience there is because I get to go inside the heart of the plane, to a place where not many people get to go. It's a definite highlight and the best feeling there is.
Despite 15 years of experience in the field, even Roman has found himself trapped inside a fighter jet turbine, which resulted in a dramatic rescue. But not even that has put him off.
I will start from the interspace, from the sealing rubber that separates the engine from the Griffin's part. Then I will devote myself to the first pre-stator, the blades, and then the first stage of the fan, and the second stage, including the inlet.
Roman has to look out for every tiny dent, most of which are caused by stones or birds hitting the plane. If he misses just one single flaw, the entire engine could be destroyed during its next military deployment.
Everything looks fine. I didn't see anything out of the ordinary. I'll carry on checking the turbine from the top now.
Zatím dobře, zatím jedeme dál.
At the same time, head mechanic Martin and his team are removing the fighter jet's outer shell and looking for further damage.
Here I've spotted something. This dark patch is just anti-rust agent. There's still enough there, so it's fine. We only need to add a new layer when it gets too dry. The waterproofing here? No, it's fine.
This involves undoing thousands of screws, each of which has its own precise location. The solution is as smart as it is simple.
Every screw on the plane has its own position. Not always every bolt is the same, so to prevent the confusion of the bolts and possible damage to the aircraft, we have prepared such a check invention. It consists of these cartons. Each carton is marked with the number of holes and by the direction of the flight. The bolts go in exactly by this order. So now, I'll try to find the right kit.
There are cables or turbine components behind every drilled hole. This means that the engineers have to adjust the length of every screw accordingly. Just one mistake would almost inevitably destroy the electronics too. The level of damage caused could quickly reach the six-figure range. Roman uses an endoscope to check the turbine's inner workings.
There are only a few people on the airfield able to perform this test, and that is precisely the problem. You need to have special training to do it, but you also need a certain flair and the right way of looking at things. We simply have to find everything. We're talking about very small parts here, which is why we need all the intuition and experience.
Roman has to take a break every 90 minutes to make sure he has enough concentration to hopefully uncover every problem, like now.
I can see some second-degree damage. It looks like a small dent from a stone. Later on, I'll compare the damage with the table to see how deep and wide it is. I'll take some photos now before I assess the damage. Only then can I see how bad it really is.
And whether damage like this will cause the plane to crash in the near future. The consequences sound pretty dramatic. A full engine replacement, performed lovingly by hand.
I am more an old-fashioned guy. It took a long time to get used to these computers. All my life, I have only been working with engines. So the Griffon is my life, all my life.
After the cold zone of the turbine, Roman now turns his attention to the combustion chamber. This is where the kerosene is ignited, generating the maximum thrust needed in equally heated situations during combat.
We're slowly working towards the most critical point. Now, I really have to concentrate to make sure I don't miss any faults. After all, we are in the combustion chamber here.
In here, damage smaller than a hairline crack can quickly destroy the entire engine. A fighter jet known as the Gripen, belonging to the Czech Army, is in for a mega pit stop. It's day 8 of 40. Roman is checking the final rotary blades in the turbine.
Oh. Uh-oh. I've spotted a problem here. I need to take a closer look from another angle. No, that doesn't look good. The turbine blade is really heavily damaged. We'll have to replace the engine.
Damage like this could quickly spell disaster during deployment. The risk of a crash is too high. The turbine needs to come out, which means a delay of at least 5 days. 2 days later, the fighter jet's weaponry system is now under the microscope. The Gripen is a multi-purpose warplane: hunt, attack, and search. Therefore, it is able to carry 8 variable weapons. Always with it, the machine gun. The Akon Mauser BK-27 can fire 1,700 rounds with a 27mm caliber per minute. Tomasz Smoler is the maintenance team's weapons expert. He knows that the Gripen is more or less perfect. But even a multi-flexible fighter jet can have its weaknesses.
The cannon is exceptionally important. Say, for example, if the pilot is not able to use rockets, then the cannon is the ideal solution. However, if I compare this one here to the one in the Tornado, I see that it may be the same weapon, but the Tornado is able to reload if it gets jammed. This plane doesn't have that option. If the shell is blocked, then we're really screwed. There's a nut here on the top. You have to loosen it and pull the crank.
Tomasz tests the Gripen's cannon again and again, after every deployment in fact. In times of peace, he still checks it at least once a year.
Oil the barrel outside and inside, then we'll carry on.
First things first, the barrel-based machine gun has to be dismantled into hundreds of separate pieces.
Utmost precision is extremely important in this job. If I put something back together wrong, forget a part, or fail to spot something, it could have fatal consequences for the fighter jet. Complete destruction or shots fired.
They follow a standard procedure. First up, washing. The soldiers carefully scrub every component. Even cleaning weapons is a dream job for Tomáš.
I collect weapons and guns as a hobby. I think it's good when a job is performed by someone who enjoys doing it, as it means they'll be precise. I put my heart into my work.
1 week later, the replacement engine has now arrived. 5 days behind schedule. But this step couldn't be avoided.
We could have had a case where there was not enough coolant to cool the engine. It could have set on fire. This almost certainly would have led to a catastrophe, and the plane could have crashed.
Luckily, it only takes an hour to change the turbine, according to the manufacturer. Roman sees that as a challenge.
How are things going with you? The line is jammed. You'll have to loosen it.
A critical moment. Roman releases the 1,050-kilogram damaged jet engine from the plane.
Okay, keep going. Yeah. That's great. It sits here at the back. Stop.
Whether it's during a mega pit stop or in the tough conditions of war, an efficient replacement process is crucial.
It is interesting that the whole engine actually hangs only on 3 points. A left and a right hinge, and the back hinge hang on such a bolt. Can we? So we go. Can I go on? Here we hang on something. Yeah, wait here. You must go to the middle, lift the pad on the bolt and forward. Good? So we can now. Watch out. Now lift it. We don't have any room for errors here. I need to be really careful now. Even the tiniest thing could have major consequences. A broken pipe, a damaged bracket, it could all be disastrous. Yes, keep going. Just like that.
Engine expert Roman is still making good time, and he seems pretty happy.
So it's in. We had a good day today. If the holes move, you can't fit the pins in. And then you have to fiddle around a lot. Half an hour down, half an hour back up. It took us an hour, as promised.
Dneska jsme udělali tu hodinu, půl hodiny dolů, půl hodiny zpátky.
They have reached their first important milestone in week 4 of the mega pit stop. However, the team is still running behind. Then they get news from Sweden, the results of the hydraulic oil test.
Roman, particles are good. It came out as class 5, low viscosity, just around the section to replace the liquid.
The oil is the blood of the aircraft, responsible for all moving parts. Therefore, the quality of the hydraulic oil is extremely important. Within the next 2 days, the mechanics will check all flaps with which the pilot steers the Gripen. And they test if the landing gear opens in an emergency situation. If this doesn't happen within a time limit, they have to replace parts.
So even if we're taking it later or longer, it would not be different. Well, that means that we will print an API gravity report. We will look at it and send an API, and then, hopefully, we will finish.
Let's do it.
Yes, I take the pump, and I pump a bit there.
The verdict? They have to pump out 20 liters of old hydraulic oil and replace it with fresh oil. This will also take up time that they hadn't accounted for. It's a setback that the team has to shake off. After all, it's not just a personal objective they've set for themselves. It is about making sure NATO's pilots are back in the air again as quickly as possible.
It's slowly moving.
Because of the purity of the fluid, it is very important to use this fluid in a closed circuit. After each use, it is necessary to rinse the tube in order to pass it over the filter, which will clean it continuously and keep the fluid in good condition.
The team starts the test with fresh hydraulic oil. The plane isn't allowed to run here in the hangar, so a generator is used to produce the pressure needed by pumping additional oil into the lines.
Good? Yes, good. I set it to 28.
The mechanics move all the wings. This pumps oil through all the lines, pushing out the last few air bubbles. The Gripen can't return to the skies until it has passed this test.
The hydraulic system is the most important element. The engine is what starts and powers the plane, but the wings are what control it. Any loss of fluid would require the plane to make an immediate emergency landing, because the pilot could lose control of the aircraft within seconds. Therefore, it is very important that we work accurately and don't make mistakes. On the other side, we have to look at... Uh-oh, now we've got a problem.
There is problem now.
Looks like we've got an issue with the generator. Now we have to figure out what happened.
Martin and his team have to suspend testing until the generator stops its strike, and that means more valuable time down the drain. The men frantically search for the problem. Then they find out that the test has to be delayed.
We can't proceed. We have to wait for our generator to shut down. At over 30 degrees Celsius, the air here in the hangar was too hot. We have to wait until it's more stable. Then we can continue working.
And yet, just half an hour later, everything is running again. The team was in luck. The onboard computer now manages the entire test and moves all the wings, one after another. It measures the response time and gives the final green light, or not.
Martin, everything's fine.
Okay.
This is, of course, the first day, the day of the hydraulic tests. And these came out well for us, so we're happy for it, of course.
Just next door, in the ejector seat workshop, The pilot's guardian angel is still waiting. Should worst come to worst, this seat will shoot 80 meters into the air. The ejector seat has to be checked every 2 years. In an emergency situation, it is the last option for the pilot. That's why the mechanics put the seat to the acid test. After every part was maintained, the mechanics reassembled the seat and include the parachute and the survival kit. In the end, they will do a functional testing to ensure it is working properly in the event of an emergency. Aircraft mechanic Jiří Wozniak has been servicing and testing high-tech seats like this for the past 20 years.
It's a job that's very close to my heart. If we make a mistake, it could cost someone's life. For the pilots, this seat is their last chance to leave the aircraft when everything goes wrong. Of course, if you do something for a certain amount of time, there's a tendency to go into autopilot. But it's important to battle your ego and focus on following the instructions you're given. If I make a mistake, I might lose a friend and colleague, and nobody wants that.
So Jiří and his colleague take great care when checking the seat. The generator applies 42 bar of pressure to simulate one of the pyrotechnic cartridges exploding. If the pin shoots out, the seat has been released. Test passed, but that's not all.
Now we simulate the ignition of the rocket engine. When it actually happens, this cable is firmly attached to the fuselage. During the firing sequence, it pulls off 80 centimeters of a cord. That activates this mechanism and pulls out the combat wedge. This activates the pyro cartridges, and gas pressure ignites the pyro cartridge in the engine and opens the isolation valve. This is where the opposite side actually released the gas pressure. With the pressure test, we check if the system is tight.
Jiří is satisfied. Everything is working. The seat belts also tighten and secure the pilot should worse come to worst.
We can release the pressure.
The pilot uses this yellow and black handle to activate the ejector seat. It can't be too heavy to pull, but then again, it can't be too light either. Otherwise, the pilot could find himself ejected from the plane simply because something got caught on the lever. According to requirements, exactly 27 kilos of tensile force is needed. Requirement met. The parachute returns to the seat just as it was when it arrived. This is one piece of equipment that Jiří prefers not to touch.
In fact, these parachutes are all packed in Sweden. Each layer of the parachute must be folded differently, so each stack is pressed by several tons for 24 hours. So actually, the parachute assembly itself takes, from what we know, about 7 days.
The final step before the explosives are returned to the seat, sorting out the large number of belts. Not a problem for a pro like Jiří. Unlike the 3.5 kilogram explosive charge that now has to go back into the seat. The 9 pyrotechnic cartridges require Jiří's full concentration. Even after 20 years, he still treats them with utmost respect.
If we work in the way that we're supposed to work, following all the documents and regulations, then almost nothing could go wrong. If I don't stick to the rules, I could put lives at risk.
The emergency kit is the only thing missing now. This yellow case helps the pilot to survive, even after a crash. It is packed full of food, fishing equipment, a knife, and some tools. One day later, back in the hangar. Today, the team is testing the Gripen's gears. The special thing about these gears is their ability to cope with the toughest conditions on the ground, even during the winter. There is one thing that Martin always pays particularly close attention to.
There could be problems if the landing gear does not lower at the right time. If that happens, we have to locate the problem as quickly as possible, solve it, and then replace the landing gear struts if necessary. That would be another delay.
I get in now.
The onboard computer once again takes charge of the test. The 3 gears have to close and open within the space of 12 seconds. At the end, the system simulates another hydraulics failure and checks whether the gear can still lower, solely using its own weight.
Okay.
Another job ticked off for the mega pit stop. But it's not the last. Martin checks the hydraulic lines.
The pilot is used to the aircraft responding immediately. If there isn't enough fluid, it would react later when turning. If, say, 2 jets were flying next to each other, and one was working properly but the other one wasn't, there could be an accident because one of the jets would be slower and would react differently.
A newly fitted joint attracts attention.
I found traces of the old hydraulic oil here, but none of the new oil has leaked. That means everything's okay.
Week 7 of the mega pit stop, and they're already 7 days behind schedule. In the weapons workshop, Tomáš Smolar has dismantled the entire cannon.
Now I'm checking the hull, looking for cracks and minor damage. These issues could destroy the muzzle. And because the pressure in this area is so high, it could end up damaging the entire plane to such an extent that it would probably crash.
A huge responsibility. Tomáš hasn't found anything this time, but he has to be 100% sure when he signs off the cannon as fault-free.
Maintenance errors are out of the question. They're just not an option. Small mistakes can cause serious problems, which can actually even culminate into the loss of the aircraft.
That's why the specialist tests the weapon one last time before returning it to the Gripen. First, he performs a mechanical check to make sure nothing is obstructing the shell casing. And then, though this may look like a cartridge, it is actually an analysis device that checks the cannon's electronics.
Good. We've done that. We've done that. Done that. When we will release the barrel, the cartridge will blast. By simulating the blast, the machine would signal any kind of problems we might have. But this cannon is functioning well.
Tomáš makes his decision. The cannon can go back in. It's the 42nd day of work for the Gripen's mega pit stop. Actually, the fighter jet should have been finished 2 days ago. Instead, Peter Sikora is installing the seat today.
It feels good to install a seat after it has been serviced. That's the result of all our hard work. It makes you feel proud to know that you've done a good job.
Nevertheless, the men can't put their feet up yet. Maximum concentration is required right down to the last step.
We can't allow ourselves to make any mistakes. That's why we work in pairs and keep an eye on each other's work. Not a single mistake is allowed. We feel confident that it will work. After all, we're professionals and we do a good job.
Deep down, of course, they hope that the seat will never really work, because they hope it never has to be activated. Week 10, the crucial point in the mega pit stop. Today will reveal how well the mechanics have done. It's not long before the final turbine test. The Grippen's jet engine can accelerate to Mach 2. That's double the speed of sound, provided that it's working properly. If the fighter jet fails, then all their hard work would be for nothing. Martin Roman and their colleagues would have to start all over again. The test flight is scheduled for just 2 days from now. Inside this special hangar, Roman leaves the jet to run at full power, a dangerous moment for the plane and all the mechanics.
This is the final check. I'm carrying a great deal of responsibility here. After this, there will be no more checks before the plane actually starts up. The engine runs at 1,200 revolutions per minute, which means that even a tiny fault could have disastrous consequences. It could damage the machine. So, who does not have to be here? Outside will stay only Gabina or Marian with Romana. Mara is in the cabin, and everyone else get in. When you sit in the plane after, I'll radio everything over to you. When we're outside in the hangar and you're in the plane, I want you to lift up your hands away from the controls.
The mood is tense. The team is prepared for an emergency. The mechanic in the plane is wearing a fireproof suit. In an emergency, the team can use the crane to quickly rescue him from the cockpit. In this safety zone, 10 centimeters of armored glass separate Roman from the aircraft. He controls the test from here.
We're preparing for the 4.
4 is prepared.
It is very dangerous now. Anything can happen to the engine. It could set on fire at any time. People are at risk, and they have to protect themselves at all times. This plane is a 5th-generation model. It's made from CFC, a very light material. There is a risk of very loud noises and strong vibrations.
The team runs through various emergency situations that could happen in the air. The engine follows along, using different settings and speeds, raising and lowering the thrust. Roman notes down the results. Then, a problem occurs. Test aborted. The measuring equipment has reported an air leak in the cooling system. Roman hopes that it's just a false alarm. He has built a special flag for cases just like this. If the cords don't move, it means there is no air leak. All clear. It was just a false alarm after all. The test continues. Now the mechanic in the cockpit has to hit full throttle and ignite the afterburners. It doesn't get more powerful than this. A heavy load for humans and the aircraft.
These tests are quite demanding because the technicians will get into that plane only twice a year. Of course, they do some preparation, but you have to try to get into the shoes of the man sitting twice a year in the plane, which is worth several billions, and he has to do the test. Because of this huge responsibility, we are constantly under pressure. I cannot be 100% sure that everything is all right because I have not seen the data yet. But basically, it looks like, according to my experience, even if we still don't have one preliminary result, which we will have right after the engine will be turned off, we could be 90% sure that the plane is okay. So, yes, I am proud.
The next morning, the maintenance team has been working through the night. The Beast is ready for its test flight.
We've finished. The problem with the oil is fixed.
Okay.
10 days behind schedule, the mega pit stop is now on the home straight. 4 major milestones have cost the team a great deal of patience, hard work, concentration, and sweat. In the space of 50 days, the team has replaced and tested the hydraulic oil and engine. The weapons and ejector seat have been removed and serviced. Everything is done. Well, almost everything.
We are always happy when a job is finished and are already looking forward to the next one. However, the aircraft still needs to be tested. We're not sure how well it will do. If it's a success, then you'll see us all cheering and celebrating.
Test pilot Mikal Danek, radio handle Marco.
Hey. I'll quickly explain everything we've done.
Following a complete overhaul, the Gripen's first takeoff will be in his hands. Hopefully.
I'm not scared. I used to get a bit nervous when I wasn't so used to it. But now, I'm experienced. Of course, you have to be careful. But I can rely on the team here and the work they do. The flight is just the last piece in the puzzle. But, of course, anything could happen.
The pilot does one last visual inspection and checks out the new engine. But ultimately, he has to rely on the maintenance team's efforts.
This is the number for the new engine. Everything is ready. Good luck.
Thank you.
The Gripen, nicknamed the Beast, makes its way to the runway. Pilot Marco is well experienced. Nevertheless, there are still butterflies whenever the plane takes off, for everyone involved.
I don't even want to think about it, but the worst thing that could happen is that the plane won't take off. However, we won't let that happen. I'm expecting the plane to be ready to fly and everything to run smoothly.
Ready for takeoff.
It's taking off. We're hoping he'll arrive back safely, but it'll be fine. We're happy when the plane is in the air. That shows that we've done our job properly. It's our bread and butter.
50 days of work, 11 mechanics, over 50 repairs, both large and small. Martin and his team dismantled the ejector seat, jet turbines, and revolver cannon, and put them all back together again. This was no easy mega pit stop. The Beast is ready to return to duty. What does it take to cut a ship into two halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. She's the most modern warship in the Danish Navy, the HDMS Upsilon. The flexible support ship is 137 meters long and equipped with high-precision weapon systems, from torpedoes to machine guns to anti-missile weapons. Thanks to its smooth and angled outer skin, the Upsilon reflects only a fraction of radar radiation, making her extremely difficult to detect. The tracking systems of the warship itself, on the other hand, are highly sensitive. The Navy vessel offers space for 2 helicopters, and its flex deck is suitable for everything from a hospital to tank transport, depending on the mission. 2 separate engines, each of them with 11,150 horsepower, make the Navy ship remarkably fast and maneuverable. The bridge, replete with the most sophisticated technology and packed in bulletproof steel. For all this to work perfectly when deployed, the Upsilon has to be docked every 5 years for a major overhaul. For this mega pit stop, engineers subject the entire ship to a complete reconditioning. The most complex of all the processes, removing and checking the marine shaft device, which in effect means cutting a hole in the ship to remove the rudder and propellers. The bow thruster will also be removed, including maintenance. The team will also overhaul the sonar and replace the bulkhead doors. And then there are the upgrades. The technicians install a brand new UV filter system for cleaning the ballast water. Painters give the entire ship a new look. Time frame for all pit stop stages, just 5 weeks. Orshoff Yard in Frederikshavn, North Denmark. The crew prepares the 215-meter-long dry dock for the arrival of the huge warship. Thomas Majin assumes command for the docking procedure. The special construction of the naval ship is a challenge, even for this experienced dock foreman.
Here we have the ship. There's the rear end, and there's the front end. And there's the bow with the sonar dome. If the weight rests on that, everything in it will be smashed. So that would be really expensive.
Under the water are bracings, wooden blocks on which the ship will later rest. Thomas has to position the Upsilon so that the fiberglass sonar dome is exactly in the gap at the front bow. His only method of orientation, the meter indications at the dock's edge.
We've done this before. It should work, I hope.
Now it's time. Tugboats are pulling the Upsilon into the dock because even a high-tech Navy ship is far too big to maneuver itself in such a confined space. Only 6 meters on each side. Dock foreman Thomas Majin directs the tugs.
Everything's fine for now.
Take a look on that side. We're getting a little close to the wall.
First, Thomas positions the Upsilon against the dockside wall. It's the only way for the front tug to be able to get out.
Let's say 2 meters for a position.
Karsten, are you ready for landing?
Yes, I'm nearly ready.
2 meters, then we are in position. We stopped.
Okay, good. Then just slack the rope again. We have slack.
They got it. The tugs leave the dock. A critical moment. If their propellers whirl up too much water, the Upsilon will start rocking and crash against the dock wall.
Slowly, slowly, slowly.
As soon as the tugs are out, Thomas Mayin begins the process of fine positioning. First step, close the gate. Then 3 powerful pumps with an output of 178,000 liters per minute drain all the water out of the dock.
It's important that the vessel is in the middle of the dock when we start to lower it down.
The narrow streamlined hole must now be centered exactly above the bracing. The marking lines, Thomas's most important orientation aid. Another decisive factor, the correct distance to the end of the dry dock. Only then will the sonar line up with the gap. The endpoint has been met. Solid wooden beams prevent the ship from tipping over as soon as all the water is out.
Okay. Do we have everything over here?
About 2 hours, then the 64 million liters are out of the dock. The first hour of truth ensues. Is the sensitive sonar dome exactly in the gap?
There's the nose. It looks good. Now I am happy. That should work.
Thomas Mayin masters the first challenge of the mega pit stop, at least at first glance. The workers immediately begin the preparations. Meanwhile, the dock foreman checks once again whether the 5,000-ton ship and its sonar dome are indeed free of damage.
Everything looks really good. It's all good. So, yes, perfect. No damage or anything.
The clock is now running. In just 35 days, the Upsilon is expected to set sail again. Project manager Martin Christensen is responsible for keeping to the schedule. In the end, every day of delay means one thing for the shipyard: exorbitant fines.
First, I go down into the different work areas and safety areas and make sure it looks like it should.
And there's good reason for that. More than 200 pit stop points are on the so-called dock list, which is the Danish Navy's order form.
Right now, I'm on the way down to the engine room where several tasks have to be done.
The warship has 2 engines, one for each propeller. If one motor fails, the other one takes over. This way, the Upsilon remains maneuverable at all times. Martin's team is to install a filter system in one of the engine rooms. First, the team kills all germs and bacteria in the ballast water. If the warship has to dump ballast while in action, the filter will protect the ecosystem.
The whole system and piping changes and the connections will be rerouted. That will take a while. The most important thing is that we are certain that we establish a place for the systems that are printed out by the ship owner.
Just one of the many challenges for project manager Martin Christensen and his team, and just one of many upgrades. In the next 5 weeks, technicians will bring the Upsilon up to the state of the art. They'll replace technically obsolete systems with brand new ones. Like this AC unit. Only if everything works perfectly will they be able to keep to the tight schedule. Nevertheless, it's important to take one step at a time. First, the team gives the Upsilon an overnight cleaning. Then, it gets down to the real work. The greatest challenge of the mega pit stop? Overhauling the marine shaft device. It's made of 2 multi-component drive shafts. In the first step, the crew dismantles the rudder blade and propeller. Then, they pull out the 21-meter-long tail shaft. To get to the intermediate shaft, the team cuts a 6-meter hole in the ship. It's the only way they'll have a chance of getting the thing out. The work is totally dependent on a truck crane at the dock. The marine shaft device is located under the ship's hull, and the fixed dock cranes simply cannot reach it. No one knows just how serious the damage could really be. During an initial visual inspection, divers did not detect anything. Only now will it become clear in what condition the Upsilon truly is, and what repairs the team will have to do in just 35 days.
We deinstall the tubes, then have an air compressor to clean the axle shoe. Then we take 2 axles out of the stern tubes.
For this, the bronze propeller blades first have to be removed, at more than a ton each. The Upsilon has variable pitch propellers. This means the propeller blades are hydraulically controllable and are able to change the angle of attack at any time. This makes the Navy ship extremely fast and maneuverable, a decisive advantage during deployment. At the same time, the team dismantles the rudder blades, and they weigh quite a bit more, a proud 6 tons. The rudders of the Upsilon are Becker flap rudders. The adjustable flap at the trailing edge makes the warship extremely maneuverable. Another critical factor in combat.
The rudder will be lifted into our shop and set up on a larger space, and also cleaned up and washed.
Even if the propeller blades appear to be very solid, the workers must be extremely careful. Just one dent is all it takes, and the part costing several €100,000 is ruined. The propeller blades are sent to a specialist company for inspection and maintenance. In the late afternoon, they've managed to disassemble the propeller and rudder on both sides. Meanwhile, another task is waiting for the truck crane, this time at the very front of the ship. Here sits the so-called bow thruster. It allows the crew to shift the bow of the ship sideways during a war maneuver. The crane operator carefully lowers the 1,500-kilogram bow thruster. 5 years of naval service since the last check has left its mark, which is why specialists will disassemble every single part in the days to come. Another extremely important item on the list for the mega pit stop: the sonar. Naval officers use it to locate submarines and mines as far as several kilometers away. Underwater, it is the Upsilon's eye and ear. Its construction and other external details, well, that's a military secret. But this much is clear. On the high seas, the dome around it is filled with water. The sonar's sound pulses shoot through the fiberglass envelope at speeds of up to 2,000 meters a second. Thanks to its cylindrical shape and its position at the front of the bow, it provides the sonar technicians with a 360-degree all-round view of the ship. To make it work even better during deployment, the technicians dismantle the sonar and give it a super state-of-the-art upgrade. But not just under the ship. The crew also works simultaneously in every corner of the vessel. Project manager Martin Christensen's job is to monitor all the work being done, several times a day. It means he covers a lot of distance.
In the end, it will be many kilometers, and then there are a lot of stairs. I think it's about 1 kilometer per round.
His next stop, the engine room. The technicians there are in the midst of preparing the installation of the ballast water treatment system. The problem? Indeed, there is no more room for the complex system of filters and pipes.
There are special components, and here is the foundation, and we have to install the whole thing and then connect it.
The main filter may already be in place, but the UV lamps for killing the ballast water bacteria also need to somehow fit inside. A total of 75 team members work simultaneously at this mega pit stop. The warship possesses 2 sets of all its major systems, but this also means 2 times the work for the shipyard crew. In the event of war, their responsibility also includes maximum security. The result of the interior check shows that 10 of the bulkhead doors have slight weaknesses, and that means they need to be replaced. Otherwise, when the going gets tough, the Epsilon will be in serious danger. Because the hull consists of 16 water and gas-tight sections connected by bulkhead doors. Thanks to this system, if the ship is hit during combat, only one of the areas fills with water. This means the ship remains afloat. If even one of the doors leaks, the ship could sink. To be on the safe side, the workers even replace the door frames. It's all work that takes time. Day 4 of the mega pit stop. One of the most complicated work steps of all is about to happen: removing the propeller shafts. Meanwhile, there's a 6-meter long and 1.5-meter wide opening in the hull. But it's the only thing making this maintenance possible. The most difficult step in the process: removing the 21-meter-long end piece of the propeller shaft. The plan? Using chain hoists. Pull out the tail shaft piece by piece. The problem with this is that the propeller shaft is hollow and therefore unstable. Too much tension or pressure, and the multi-million-euro component will bend. Mechanical engineer Jorn Rabjerg manages the highly complex removal process. His team must carry out each step precisely, both in terms of sequence and timing.
There's an oil distribution system ring that should also be taken out. And we have to be careful when we take it out.
Only after removing them will Jorn and his team know whether the drive shafts have been damaged at all, and if so, to what extent. Time for final, critical instructions.
Karsten, those bolts over there are supposed to lie on the scaffolding here. We have to find them.
Okay, we'll do that.
But before you put that on... Yeah, that's fine. Perfect. Now I have to go to the other side.
Jørn's team works with 4 chain hoists at the same time in order to exert as little concentrated pressure as possible on the propeller shaft. Meter by meter, they pull the shaft backwards. Technician Karsten Dovada knows exactly what to look out for.
We do this work with the propeller shafts very often. We have to be careful. Otherwise, we'll ruin what's inside here.
This applies in particular to the tail shaft mounts. They contain extremely sensitive bearings that run around the propeller shaft.
We are pulling on carefully, so it comes out further.
The further the team pulls the shaft out, the greater the risk that it will bend under its own weight of 22.5 tons. Half of the job has been completed. Now the dock crane takes over. But that doesn't make it any easier.
The problem is, it hangs like this because it's so long.
The diameter of just 40 centimeters is very small in relation to its length. This makes the tail shaft extremely unstable. After a good 3 hours, technician Karsten Dovada and his colleagues leave this problem behind until they have to install the shaft again later.
We are happy.
But what condition is it in? At this very moment, still completely unclear.
We're measuring the axle now. And if it doesn't have the right dimensions, we'll have to do something about it. But it looks very good. But we'll only know tomorrow when we measure.
This also applies to the tail shaft on the other side of the ship, because that's next. Meanwhile, technicians in the engine room are already preparing to remove the 8.5 meter long intermediate section of the propeller shaft. Martin Christensen's team is getting good time with the Navy ship's mega pit stop. Duration of the tail shaft removal, just 1 day.
We have definitely completed one of our bigger projects, and it has gone better than expected, so we're happy.
But the crew is only just now transporting the propeller shaft parts for their critical inspection. Everyone hopes to reinstall them in a couple of days, at the latest. Meanwhile, about 60 kilometers south of the shipyard, more specifically in Aalborg, specialists are working on another important part of the warship, the bow thruster. First, they overhaul all the parts. Then, technicians Benjamin Vammen and colleague Morten Bjerring reassemble the rudder. Both hope it works, potentially even better than before.
We've packed the outside, then we are about halfway. We will have to be a little careful. Then we will have to make sure the bearings are inserted properly, and then it is together.
Time for the test. The rudder is placed in the housing. The gearbox inside transmits the power of the engine to the bow thruster propeller.
This is the contact surface for the gears, and we have the bearings out of it, and it looks a little worn in the profile.
During assembly, the technicians first heat the individual parts with electricity. Initially, this causes the metal to expand. It contracts again when the assembly is complete. The result, ideally, everything is 100% waterproof. The only thing left is the cleaned and polished propeller. It's made of aluminum bronze with an especially saltwater-resistant alloy. A critical moment. Technician Morten Bjerring connects the propeller with the control system.
This is the control. There is a connection to this here, which has a sensor on it, so you can see from up on the ship where the propeller is. This is also a really important piece of equipment, so it should be fastened.
Time for the function test. The technicians connect the bow thruster's hydraulic control system to a warship simulator machine. Looks good at first glance. And at second glance as well. The variable pitch propeller can steer thanks to the control of the individual propeller blades in every direction, defined by the warship simulator.
The results of the test show that the blades are moving fine, and we just have to have it finished off and ready for the client. It was a successful test.
Test passed. In just a few days, the workers can reinstall the bow thruster into the warship. In the meantime, the ultimate test of the mega pit stop is coming up at the shipyard, measuring the propeller shafts. None other than Peter Poulsen performs this one. He and his team are the specialists for marine propeller shafts worldwide.
I'll place the rollers on the axle, where it's prepared for the test, and then we turn the axle around. Then we put a clock on, and then we measure.
A test in which every single millimeter truly matters. Peter's special dial gauge shows whether the propeller shaft is deformed, and if so, how much. This eminent authority compares the results with the target values. Maximum permissible deviation, 3 millimeters, and this at a total of 10 measuring points. The further the dial gauge pointer moves, the worse it looks. And the result?
I think the axle is crooked, so it needs to be taken up and straightened.
A catastrophe. Based on the results, the expert suspects that the shaft has deformed due to excessive acceleration during a military maneuver. The results of measuring the second shaft are still out.
From port side, this axle here, in the second measurement, is a little better than the other.
A little bit better actually means almost as bad. And for the shipyard, as well as the Navy, it also means repairing both propeller shafts. Apart from the costs, it is estimated that this will take about 3 weeks. The delivery date of the Danish naval vessel is in serious jeopardy. Time for a crisis plan.
Well, it isn't clear where we should go. But the axle there, that is a critical area. So we have to look at the pilings. So now, we should go to the meeting room, and then we can discuss what we should do.
The problem? If not repaired, the propeller shafts could soon damage the drive itself. Project manager Martin Christensen has to have them repaired, and he has to absorb the impending loss of time as much as he can. The subsequent repair of the propeller shafts takes place in Hirtshals, just 45 kilometers away. In the first step, specialists stretch the propeller shafts. Then, a laser applies very fine layers of liquid metal to compensate, as much as possible, for the remaining imbalance. Technicians measure the propeller shafts repeatedly. It's a game of time, and nobody knows how it will end. Halftime at the mega pit stop for the Danish Navy ship. While the shaft is being repaired, project manager Martin Christensen pushes forward with all the rest of the work still to be done, such as the check of the 245-meter-long anchor chain. At least here, everything's fine. Installation of the new bulkhead doors is also making good progress. The crew is already preparing the frames for the 170-kilogram doors. They have to be 100% airtight. It's the only way the bulkheads can prevent the ship from being flooded in combat. To be absolutely sure, technician Kim Skolbæk Sørensen and his colleague are testing each and every one of them.
That leads to our living area. If there were to be an accident here, it is critical that we can seal this off completely so nothing happens to the people inside. It is a safety feature.
For the final test, Kim first cleans the rubber seal thoroughly. Then he puts ordinary chalk on the door frame. And then closes the door. Done.
And there we have the results, 100% tight. If there had been an area without chalk, we would have had to do something to correct it. But you can see the chalk all the way around, so it is exactly how it is supposed to be.
The idea behind it is as simple as it is ingenious. If the fine chalk dust becomes visible when the door is closed, the pressure is high enough. And it proves, in an emergency, not a drop of water will get in.
This is the simplest method, but it is always 100% correct. No water gets past if this test has passing results. This is what experience tells us. Now the hour of truth. It looks fine. Chalk, chalk, chalk. Yes, perfect.
This door also passes the test. Now technician Kim and his team continue the test on the other doors. If he makes a mistake, the whole ship could sink extremely quickly, if attacked.
We have now checked all the doors with new seals, and we have run the chalk test like we usually do. There is nothing wrong with them, so they need no further repairs. Otherwise, we would have made repairs. Everyone is happy, no water is getting in. That was the last 100% test of seals.
The specialists in nearby Hirtshals are still working on the propeller shafts. The decisive and hopefully final step: inspect the metal for any damage that may have occurred during the work. Materials tester Jan Hedemann Algonsen uses what is known as a dye-penetrant inspection.
I'm looking for tiny indications on a white background.
The color red serves as an indicator.
The next thing that happens is it has to sit for 20 minutes and penetrate the material.
If there are inclusions or cracks in the metal, the paint is absorbed and then sets. After 20 minutes, the team cleans the propeller shaft millimeter by millimeter. Now, the last, absolutely critical step.
Now we are putting on the developer. Yeah, right down the neck.
The so-called developer is a fine-grained powder. It makes the smallest residues of the red color invisible, thus indicating defects. In the worst case, the propeller shaft requires time-consuming reworking. And indeed, the developer shows faults. The team immediately marks the critical points.
We found some indications of it, so it has to be repaired. And in a few days, it should be done.
A serious delay. The ship is supposed to be complete in 10 days. The mega pit stop would then also be over. But even if the shaft is finished in time, the installation is extremely complex and complicated. First, the 8.5-meter long intermediate section must return to the engine room through the tiny opening in the hull. One bump by the workers, and the freshly serviced propeller shaft is damaged. The best-case scenario is that the team affixes the bearing and closes the hole. Only then can it mount the end piece, propeller, and rudder. Mechanical engineer Johan Rabjak uses every remaining minute to make the most of this shrinking window of time. His dock crew installs the intact intermediate shafts in the ship.
Yesterday we set the new stern tubes in place. After installing them, we put the middle axle in place. The next thing is to assemble it in the machine room.
But to do this, the workers have the mammoth task of getting the 8.5-meter long and 6.5-ton heavy intermediate section back into the engine room. For technician Simon Bostrup and his colleagues, this, like everything here, is a major challenge.
The hardest thing right now is to get the axle in, and then we need to assemble some bearings.
Clearance when feeding in the propeller shaft? Just 10 centimeters. Weight and length make the whole thing even more difficult.
I have done it once, but normally when we pull axles, it is not this caliber at all. We pull out the propeller shaft itself. This is really special.
At full power, the propeller shaft operates at 1,500 revolutions per minute. Monumental forces are at work here. Simon and his colleagues, therefore, spend hours fine-tuning each bearing to the millimeter. This process alone, including sealing the hole, takes several days. The Navy ship's delivery date is creeping closer and closer, and there's still no sign of the repaired propeller shaft. Meanwhile, teams are repainting the Upsilon with a meager 4,000 liters of fresh paint. The time has now come. It's day 30 of the mega pit stop, and there's almost a standstill. Technically, the Upsilon is supposed to leave the dock in 5 days. While the crew works intensely under the ship, carrying out the work still possible in this state, everything above deck is almost ready. The brand new ballast water treatment system has since been placed in the engine room. The installation is complete, including 50 meters of newly laid pipes. Everything is going according to plan, except for one thing, which is going to be tough on the crew, despite all their successes. They'll have to wait. 3 days later, almost all the work on the ship is complete. The team is still hoping that the propeller shafts will arrive on time. For project manager Martin Christensen, all that remains is a final check of his team's finished work. Despite all the complications, he is confident that the ship will be delivered without a significant delay.
It is a big problem for us that we had to wait for the axles. It delays a lot of other work, but as soon as we have the axles, I'm sure we'll get the job done quickly.
Then, a crucial message arrives. At least the first of the two drive shafts is back. The starting shot is fired. Dockmaster Thomas Mayin immediately initiates installation of this sensitive part of the warship. And this is at least as complicated as taking it out.
We hope everything is ready. When the crane is ready, we'll try.
First thing to do, get the shaft out of the hull as quickly as possible. And make sure there's perfect cooperation between the dockmaster in the vehicle and the operator of the indoor crane. Almost half an hour for 10 meters. Under these circumstances, perfect. Now the dock crane takes over. Thomas Mayin double checks every suspension.
I think this one's longer than the other. It's a little hard to see.
All right.
A job against time, and yet with maximum precision. Even just the tiniest error, the repair work that costs millions would be a complete waste.
Now we just need to get it down in the dock. And in.
Tension remains high. The team waited almost 3 weeks for the propeller shaft. Now, everything has to proceed perfectly.
Now that we can get the shafts in, we can start some of the work that has been waiting on the installation. Until now, I'm satisfied. We've quickly brought the shaft down into the dock and expect to have it rigged in shortly.
The next step is no less delicate, because not only the propeller shaft itself is sensitive, but also the bearings inside the mounts. If they hit each other too hard, all the work will have been wasted, to say nothing of the time pressure. Carefully, piece by piece, the team pushes the shaft back into the ship. Finished. In the shaft tunnel, technician Simon Bostrup and his colleagues then have to reconnect the tail shaft to the intermediate section.
You really have to be careful when putting in the axle, that you don't damage anything. These are expensive things we work with, so we are careful.
This is because the bearings and seals prevent water from penetrating the ship along the propeller shaft. All this only works if every part fits exactly to the millimeter. Then, in the early evening, success. Well, at least 50%.
Now we're done.
The first propeller shaft is back where it belongs.
The axle is in and we didn't scratch the rod or anything. We are very pleased. It has exceeded our expectations. It is a major milestone on the project, so we are very happy that we got the axle in. Now we are halfway there. We just have the second axle to go.
The only thing left: mount the propeller and the rudder, all several tons of them. And then, 2 days later, the hour of truth. Propeller shaft number 2 finally arrives. The team is only slightly behind, but they're still able to keep the loss of time within limits. Now it's down to one last sprint in this race against time. Day 37 of the mega pit stop. With a delay of only 2 days, project manager Martin Christensen and his team are completing the final work, and this despite all the problems. He's proud of what his people are able to do, right up to the last second. 75 people overhaul a complete high-tech naval ship in 5.5 weeks, working 26,000 total hours, 8,000 square meters completely renovated, painted, and finally, state-of-the-art. From propulsion to sonar to the airlock doors, from innovations such as the new ballast water filter system to the drive, the Upsilon is ready for its next mission. Well, almost. Just one thing left to do: the test run. Project manager Martin Christensen also has the final responsibility here.
We're ready. I was just out checking the last of my outstanding tasks. Everything is ready for launch.
The float test. As simple as it is crucial. It will soon be clear whether the team has closed and welded all openings and holes to 100% water tightness.
Everything should go just fine. There is a tiny risk, but not much. It has to be watertight. We hope so.
The critical moment. The Upsilon floats at a water level of 7 meters. Meanwhile, inspections are performed inside the huge naval ship. Just one small leak, and the team has to abort the check. Two hours later, the dock is completely flooded, and the warship holds tight.
We just got word from the ship, and everything is sealed. Despite the problems we have had during the project, we have been able to deliver nearly on time. And we are ready for the client to take over the ship.
The mega pit stop. It's over. After 37 days, the Upsilon is ready for deployment once again. The tugs take the warship back out to sea. And she sets off from there to the next top secret mission. What does it take to cut a ship into 2 halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. The Peter Pan, a monstrous car ferry. 2 football fields long and 35 meters high. The Swedish ferry can fit 540 cars and 744 passengers. But that's not enough anymore. Peter Pan needs to grow even larger and increase its cargo capacity by 25%. What the engineers have in store for this mega pit stop is prodigious. They will lengthen the Peter Pan from its current 190 meters to 220 meters. To do so, they will cut the ferry into 2 parts and insert a 30-meter-long section. Lengthening the ship means changing its flow properties. Thus, the Peter Pan's bulbous bow has to be swapped out and its engine overhauled. At the stern, an additional deck provides space for over 100 extra cars. For all this, the team only has 75 days. The Baltic Sea, just off the coast of Germany. The Peter Pan is on the way to its mega pit stop. Swedish Captain Hans Windqvist has been in command of the ferry for 2 years. The purpose of his last voyage with the old Peter Pan is to arrive at the shipyard on time.
There were a couple of questions from the shipyard. If we were on time or running late, or... Even the agent and the shipping company were in touch. So yes, I've had a couple of calls and some emails.
Time is running short, even before the mega pit stop begins. 60 workers are on board during this final crossing to the shipyard to prepare the ship for its expansion. In a few days, the workers will cut the ship apart along these markings. The paint has to be removed along the cutting line beforehand, from a surface totaling nearly 1 kilometer. While everyone works at full throttle below deck, the Peter Pan approaches its destination at full speed. German dry docks in Bremerhaven. The shipyard specializes in repairing and modifying ships. A team of 40 workers has been working for several weeks to prepare the 215-meter-long dock for the arrival of the Peter Pan. Time for one last check. Project manager David Porath measures the dock blocks one more time. This is where the ship will rest during its mega pit stop. He and his team have planned the car ferry lengthening for nearly a year.
I also have to say, this is the very first ship expansion that I'm actually responsible for. I worked on one before, but I've never been in charge of one in that sense. I wouldn't say I'm nervous, but there's a certain amount of tension. The type of work we do here is challenging, for sure.
David Porath carries the responsibility for the mega project. The shipyard will only be able to meet the delivery deadline for the new Peter Pan if all the work goes according to schedule over the next 2.5 months. That afternoon, the ferry arrives at its destination on time. Tugboats maneuver the steel colossus into the shipyard. Maneuvering on its own in the narrow basin would be unthinkable. Captain Hans Windqvist pulls up to the pier for final preparations. By early evening, everything is ready for docking. The man responsible for the smooth operations during this process is Dockmaster Frank Herbst. He's been in charge of the dock for 25 years, but expanding the Peter Pan is an extraordinary challenge, even for him.
This is a serious undertaking. It even has me nervous.
Frank Herbst floods the tanks of the floating dock, causing it to sink. The massive volume of 35 million liters of water rushes in. Frank Herbst only has about 2 meters of leeway on either side of the ship during docking. After the expansion, the ferry will extend beyond the front and back of the dock. The front section will not be moved during the whole mega pit stop. Frank Herbst has to position the ship precisely on the bracing. After an hour, the dock is low enough.
Yes, Hook's here. So the dock is almost where we want it. We have a depth of 6.2 meters. You can bring her in now.
Hi.
Hi.
Everything okay?
Yes, it's starting now.
Captain Hans Windqvist guides his old ship in one last time. A bit of nostalgia hangs in the air.
It's a bit exciting to be growing by that much. And this is our last time driving the Peter Pan, so to speak. It's going to be rather difficult to take on such narrow passages as soon as we're 30 meters longer.
Turning the Peter Pan in front of the dock, unthinkable. Hans Windqvist has to bring it in backwards.
I've got to get through here. I must look at the corner.
Frank Herbst is the captain's eyes. He tells him how much space there is left. One small mistake and the ship crashes into the dock walls. They did it. Hans Windqvist did a pristine parking job.
We're almost there. We just need to get it done now. This is perfect.
You can stop now. We still have about 5 meters to go. We'll do the rest.
The workers pulled the ship to the designated final position using rope winches.
That's fine. That's where the ship will be cut.
The first hurdle has been overcome. Now, the mega pit stop can begin.
We're happy. The boat is parked and sitting on the blocks. It went well, and we did it quickly. We can be pleased with the result and call it a night soon.
During the night, the workers pump the dock back up. Only now can we finally get a close look at the ferry's impressive dimensions. It's as heavy as 25 A380 airplanes and as high as a 20-story building. David Porath is already making the rounds again early in the morning. He's checking the preparations for cutting the ship apart. His team now severs hundreds of cables, lines, and pipes along the cutting line. The ship can only be reassembled later if everyone works carefully now. Thus, they have only 5 days for this step. To save time, David Porath wants to already start cutting the first sections.
All the necessary access work has been completed, and we can start here now.
The greatest challenge in the process, guiding the complicated cut. The shipping company only wants to increase the cargo space. To leave the passenger area untouched, the ship engineers apply a very special cutting method, the Z-cut. First, there is a vertical cut from the bottom to a height of 19 meters, followed by a horizontal cut of 35 meters. In between, after 17 meters, they cut along the funnel chimney wall. That's the only way to leave the whole passenger space in one piece. To maintain the structural integrity of the steel colossus for as long as possible, the team cuts from the inside out. They use a method which is known as autogenous flame cutting. A mixture of oxygen and acetylene gas heats the steel along the cutting line and then burns it at 1500 degrees Celsius. An important milestone has been reached. The project manager is satisfied.
That's exactly the way it's supposed to be. We've started cutting the ship. That's good.
The team has to slice along a line that is 1 kilometer long. Clock is ticking. From now on, they will work 24/7. In total, David Porath's team needs 5 days. Then they have done it. The huge ship is cut in half. There are just a few centimeters of space between the two parts of the ship now. The Z-cut leaves the passenger area freely suspended after removing the aft ship. Due to its heavy weight of 850 tons, it would collapse without additional support. Thus, a supporting system stabilizes the overhang so that the engineers can push the stern backwards. After 18 meters, they assemble 4 support towers to transfer the load step by step. In total, 6 support towers are stabilizing the Peter Pan's foreship to make room for the middle section. Moving the back half of the ship is a mammoth undertaking. It weighs 6,500 tons. This important step is his responsibility, Kai Hoyer. He specializes in transporting heavy loads. Kai Hoyer and his team push the 80-meter-long aft ship away from the front half using a hydraulic sled system. While preparations are being made under the hull, project manager David Porath checks the cutting line one last time. Pulling the halves of the Peter Pan apart will only work if his team has made a clean cut. Even though David didn't find any flaws, he is concerned.
There are so many edges that we can't expect everything to go completely smoothly. There are going to be some sections that we'll have to cut through again.
There is a risk of steel snagging along the lines of the cut, so the project manager only wants to move the aft ship a few centimeters to start with.
Nastro to all teams, everything ready to move. Is Lastro ready too? Let's get started.
The cylinders exert 210 tons of pressure to start moving the aft ship.
10 centimeters? 10 centimeters. Yes, I stopped. That was the first 10 centimeters.
Time for a check. In a worst-case scenario, parts of the ship could bend out of shape if the massive steel walls get caught. This would make it impossible to reassemble the car ferry later.
Can we start pushing? Can we start pushing? Yes? Good. Okay, good. We can start pushing now.
Little by little, Kai Hoyer pushes the halves of the gigantic ship further apart. But then, the joists are at risk of snagging.
Stop below, please.
Copy, stop.
The workers have to go back to cutting. The ambitious schedule is in jeopardy. While David Porath's team tries to solve this problem, the midsection of the ferry is being made about 200 kilometers away at a shipyard in Hamburg. Its dimensions, 30 by 30 meters. It will be inserted into the Peter Pan as a finished part. Engineer Simon Wittek is responsible for the construction of the so-called mid-body.
We still have to grind a little bit there, and these pores have to be removed. You have to check everything, every single welding seam, to see if there are any inclusions or pores left. In the worst-case scenario, water can permeate the sides. No one wants to think about these things, but that is what could happen in the worst case.
The center section is made up of 22 prefabricated components. These sections can weigh up to 100 tons. Almost like they're building with Lego, the workers put together all the components until they form a complete section of the ship. To make sure it will fit into the Peter Pan later, the ends are produced with an extra 50 centimeters of safety margin on each side.
It's almost like a baby. You watch it grow, but I also look forward to the moment when everything comes together. I ask myself if everything will fit, but I'm proud to just be a part of it.
There is still a lot to do, and things are tight here too. According to the timetable, the engineers will already be installing the midsection into the Peter Pan in 7 days. Back in Bremerhaven. This is where space for the midsection is being made. But there are problems. Several steel beams have snagged. Now the workers have to cut again. Precious time is being lost. Kai Hoyer tries to stay calm.
When there are this many unknown rough edges, you just have to be a little patient. That's just the nature of it. We are happy that it can be solved like this.
At this point, Hoyer's team has only moved the aft ship back by 2 meters. They've been playing the waiting game for hours. But then...
Go for it. We're ready.
All right, we're gonna start.
Time for the next attempt. Now they will see if the team took care of all the problem areas, or if Kai Hoyer will have to call another sudden stop. Finally, it's working. Kai Hoyer pushes the 6,500-ton section of ship back further and further. An hour later, they've tackled the first 10 meters.
Wonderful, we did it.
The aft ship of the Peter Pan has finally been properly separated from the foreship. Project manager David Porath's team lost half a day, but he is happy anyway.
We had a couple of snags here and there, but we're able to solve them relatively quick and easy. It went well, as you can see. Anyway, we're happy that we have this milestone behind us now. That's it, yes, we're happy.
David Porath is one step closer to his goal of expanding the Peter Pan. Over the next few days, bit by bit, his team slides the aft ship back another 18 meters, and they set up the supports for the overhang. When they're done, there's a gaping hole around 30 meters wide between the ship's 2 halves. 3 weeks after the mega pit stop began, the most critical step of the project begins: inserting the midsection into the car ferry. To do so, the lower parts of the cut surfaces must be sealed up watertight before the dock is flooded. To protect the sensitive technology of the engine rooms behind the panels and prevent the ship from sinking. Tugboats pull the aft ship away to make room for the prefabricated mid-body. The engineers have to align it precisely to the foreship. Otherwise, it is impossible to connect the 2 parts. Then, tugboats bring the aft ship back in again. Day 29 of the mega pit stop. Today, the aft ship is scheduled to be undocked. David Porath and his colleagues developed a special system for this. Giant flotation units are designed to ensure that the rear half of the ship sits steadily on the water.
This is quite an adventure. This has never been done before. But the company that manufactures these sacks has been making things like this for a while, so it should work out just fine.
The hull becomes narrower towards the back. This means that the ship has less supporting surface in that section and would tip without support. Each of the 8 air sacks has 103 tons of buoyant force. In total, the system has 1,100 tons of buoyant force, sufficient according to calculations. But that is not the only risk factor. Huge steel panels are supposed to make sure the engine rooms remain sealed. These welding seams have to hold, otherwise the sensitive technology behind the panels is in jeopardy. Water in the engine room would be a catastrophe. While the team in Bremerhaven prepares to float out the aft ship, the midsection for the new Peter Pan is ready for its journey from Hamburg to Bremerhaven. 2 tugboats haul the 1,500-ton part of the ship over the River Elbe and the North Sea. It travels a total of 220 kilometers by sea. Its scheduled arrival at its destination is already the next day. In Bremerhaven, the aft ship still needs to be taken out of the dock.
We're all a bit tense to see whether all the theory will correspond into practice. But we're happy that it's finally starting to happen.
The job is already 2 days behind schedule. It is extremely important for David Porath and his team that now everything goes smoothly. The responsibility for this task is again in the hands of Dockmaster Frank Herbst.
Werner, please start lowering the dock.
Yeah, okay. If you have the okay, I'll get started now.
In order for the aft ship to float, Frank Herbst and his team now slowly lower the floating dock to a water depth of 5 meters. Initially, everything goes according to plan. After half an hour, the 2-meter mark has been reached, but something doesn't seem right.
Hold on, Frank.
Frank de Lasse.
Frank, please go back up to 1 meter.
Okay, back up to 1 meter. We'll go back up to 1 meter. Maybe a screw connection.
There is a problem in the engine room.
Air was coming through. And where air can get through, water will come through at some point. That's why we stopped. Now we're quickly putting in a weld seam.
A weld seam in the temporary wall isn't watertight. And not just there. David Porath's colleagues discovered another leak.
It's like an emergency room.
Yes, exactly.
The leaks are still tiny. The problem, the water pressure from the outside could quickly change that. At the very worst, the aft ship will run full of water and sink. David Porath makes sure the weld seams are reinforced in the critical places.
Frank, then please go back to 2 meters. Confirmed, 2 meters.
Then I'll head over there.
Centimeter by centimeter, Frank Herbst lowers the dock back down. In the meantime, workers check all the critical points on the ship. At a water depth of 5 meters, the aft ship lifts off the dock blocks and begins to float. It's only then that the team can finally be sure if the welding seams hold or not. After 3 hours, only 80 centimeters are left until they reach the critical mark.
David to Lasse.
David, go ahead.
We have to weld here again.
Okay.
Yeah. Water's really coming in. We actually wanted to do this in daylight. But I think that's not going to happen.
One of the repaired spots still has a leak. David Porath has the seams doubled on the bulkheads. If they continue to leak, they may have to abort, and the shipyard will lose another valuable day.
We've got to get it out today so we can put the next piece in tomorrow.
The seam is now double reinforced. Frank Herbst continues lowering the dock, very slowly. So much is riding on this moment for the whole team. David Porath checks the critical spots once again. And then...
Everything's fine. Everything's watertight here. Yes, I'm happy that it's fixed.
David Porath can breathe easy for a moment. But there is still another risk factor. The giant flotation system at the back. It is supposed to keep the 80-meter-long aft ship in a steady floating position.
Let's hope everything in the back will float right. I mean, someone did all the math on this. I just hope that it stays level.
Frank Herbst can't do much more than hope now. They will only be able to know if the system works, or doesn't work, if the aft ship is finally afloat.
We're about to really start floating. Pull hard!
Come in, Mr. Herbst.
Go ahead.
The stern is floating.
Haul in the slack in front. Keep going with both spills on the south side.
They did it. The aft ship is afloat, just like the math said it would be. But there's no time to celebrate success just yet.
There's no turning back now. Yes, it's always kind of nerve-wracking. It's just nerve-wracking.
First, Frank Herbst and his team move the aft ship a few meters out of the dock using rope winches, because the tugboat's draft is too deep to enter the dock. Attaching the tugboat requires full concentration. If it comes too close to the stern, its propeller could rip open the floating system's air sacs. But everything is running smoothly now. The tugboats pull the aft ship a few hundred meters further down the pier. It will remain there for the time being. According to the timetable, it will be back in the dock in 2 weeks.
Everything's fine. We'll fasten it now and then go home. Yes, that's what we'll do.
The whole team breathes a sigh of relief.
Super. Great. We got the thing out. Everything worked out pretty well. That's good. I'm satisfied.
The team has overcome an important hurdle in the mega pit stop. The next step, docking the midsection and connecting it to the foreship. Day 30 of the ship expansion. The workers prepare to dock the midsection. They're about halfway through the time they've been given to deliver to the shipping company. And the Peter Pan has a long way to go before it's actually finished. The team is 3 days behind schedule, but they can't let that distract them. They're going to need to give all the concentration they can muster into the docking process.
We're about to start. We have to approach from 30 meters beneath the ship, which means we can't come in crooked by even half a meter on the other side. It has to be positioned extremely carefully.
Two tugboats maneuver the steel colossus to the edge of the dock. But the tugboat at the front can't drive into it. The mid-body is now floating without being guided. It is only being pushed by the second tugboat.
Five meters are in.
Count down the last 10 meters, okay?
Will do. I'm heading to the back.
The team stabilizes the midsection with ropes. That's how they keep it from crashing against the dock wall.
It's going well. Sometimes it's also good to have some things go smoothly.
Meter by meter, the dockmaster and his team move the midsection up to the first braces. They've done it. The steel colossus is safely in the dock. The next step, aligning the mid-body with the foreship with millimeter precision. Even the tiniest deviation in one direction will make it impossible to connect both ship sections. One man is responsible for the precise alignment of both sections of the ship. Surveyor Jan Munkholm. As the Danish member of the team, he is considered an eminent authority in his field and has even worked for NASA. Even though both parts weigh thousands of tons, now it comes down to millimeters.
Which one do you want to have?
It's too high now.
What is too high?
Section.
Yeah, okay.
So we need to move the front to the side. Load.
The midsection is crooked. To make it level, workers place weights on the top deck.
How much? 60. That's fine. Tim, we read 60 here.
After about 3 hours, not only Jan Munkholm is happy.
Okay. Back. Okay. Now, be down there. Be down. Be down.
We aligned them within 1 or 2 millimeters, and now I'm happy.
The next step, pumping the dock up and pushing the midsection meter by meter towards the foreship. Then it's the welder's turn. In total, 4 kilometers of weld seam will be needed to connect both sections. 2 weeks later, the old foreship and the new mid-body have been joined to create a 140-meter-long section of the ship. Now, David Porath's team can bring the aft ship back into the dock and connect it. The following morning brings a heavy fog. Visibility is under 30 meters. This is catastrophic for the team. For the docking process, the weather conditions have to be perfect. Otherwise, it is just too risky. But the shipyard can't afford to lose another day. In 6 weeks, the Peter Pan should go into service again for the shipping company.
We need visibility of at least 100 to 150 meters, and we don't have that. But we don't have any wind, which is good. Now we have to decide what to do.
The responsible port pilot has to make the final decision.
We hope he'll do it. You have to be able to see the tugboats in the dock. When I look over there, I don't even see the dock anymore.
The pilot gets a feel for the situation from the deck of the ship. Visibility is close to zero. Parking the steel giant with millimeter precision in these conditions is practically impossible. One more time, Dockmaster Frank Hurst goes through all the eventualities with him.
We're going to start now. We're moving now.
Despite the bad weather, the team is now attempting to dock the 80-meter-long aft ship. Everyone's nerves are on edge.
Throw it in! Throw it in the water! Take it away.
The maneuver once again requires the utmost concentration. Once it gets going, the 6,500-ton steel giant isn't easy to stop. If the poor visibility causes the pilot to overestimate the distance, the aft ship could slam against the dock. The tugboat at the front once again drives off before it reaches the dock. Now, the team has to get the steel giant under control as quickly as possible with their ropes.
So, careful here. Go over there. Yes. We'll go straight for the long ones.
Things are getting close on one side. Really close.
The back has to move a little more. Now we have it. Oh, the sensors. Christian, pull a little harder.
A quick moment of shock, but then the dock team has the floating part of the ship back under control.
Keep pulling it through. Now we're winning.
The back of the ship is in the dock. Meter by meter, the team now uses rope winches to pull it towards the front section.
That was really something you don't see every day.
They did it. 44 days after the mega pit stop began, all parts of the Peter Pan are finally in the dock.
Now you could say we've got the band back together. We've got a lot of work done, but we still have a great deal ahead of us.
David Porath's team now has to reconnect the individual pieces to make a functioning ship again. And there are only 4 weeks left before scheduled delivery to the shipping company. The 40 welders have a mere 7 days to connect the aft ship to the front section of the ship. This task requires them to weld 4 kilometers of seams. All parts of the ship need to be permanently welded back together. before the electricians can begin their work. 120 kilometers of new cable have to be laid and connected. The engineers also replace the Peter Pan's bulbous bow and give both of the Peter Pan's drives a good general overhaul. Despite its longer size, the Ferry's performance needs to remain the same. Specialists overhaul the two huge pod drives before fine-tuning them. Just one of these drives alone can deliver 11 megawatts of power. Meanwhile, at the front of the ship, another team inserts a new bulbous bow. It minimizes resistance and fuel consumption by slicing through the water in front of the ferry. After all, the plan is that the Peter Pan won't guzzle any more heavy fuel than it did in the past, even with its new expansion. A team of painters makes sure to cover up the seams welded just a few days ago. David Porath and his team of several hundred people work around the clock, and yet they are still only able to deliver 2 weeks after the planned deadline. It's even more important that they don't discover any problems during the upcoming leak test.
The suspense is building. The ship is set to return to the water for the first time in weeks. We are checking for leaks and making sure all valves and welding seams are closed and sealed. We're about to start slowly letting water in.
The team is tense. The Peter Pan was originally supposed to be back in service 2 weeks ago. On the ship, David Porath divides everyone into teams for the inspection.
We're checking all the tanks, making sure that all the valves are sealed. There would be nothing worse than finding water leaks in.
Will the welding seams hold?
We're letting water in now. We'll set the ship down to a depth of 1 meter, and then we'll check everything.
If water penetrates the hull, Frank Herbst can quickly pump the dock back up. "20 minutes later, and they are ready. The dock is at the right depth. Time for the inspection to get underway. An old acquaintance joins David Porath to climb through the tanks, Captain Hans Winquist. He is keen to see for himself whether everything is sealed. The most critical area is the center section. This is where the ballast water tanks are located. They are there to balance out any uneven loads. Empty cells also keep the ship buoyant.
Nothing's here. Everything's dry.
Everything looks good to begin with. But then,
now we're in the ballast water tank. We've water here.
a nasty surprise. This could delay the ship's delivery by several more weeks. The team has to find out where the water is coming from as quickly as possible.
The sections in this area were put under pressure, and what we see here is basically just leftovers from that. I wouldn't say this was a water leak at the moment, but we have to ensure that we don't come to wrong conclusions and that water starts leaking in places where we are no longer able to repair when the ship is afloat.
All clear. The test can continue. Now, Frank Herbst lowers the dock to a depth of 4 meters. This increases the water pressure on the ship's hull, and thus also strain on the welding seams. The team once again meticulously checks every corner of the Peter Pan's hull. The inspection lasts nearly an hour.
Everything's fine. Everything's dry.
The welding seams are holding.
We still have a little bit to do, but we're on the right track, and in a few days we can return to regular service.
The inspection team didn't find anything in the other parts of the ship either.
This is just what we expected today. Everything is prepared properly.
The team needs 5 days for additional system tests. Then it's ready. The brand new Peter Pan is finished. Polished, painted, and an astounding 30 meters longer than before. It emerges in all its glory. 1,000 workers spent 400,000 hours on this mega pit stop and welded over 4 kilometers of seams in the process. The ferry now has space for over 100 extra cars.
You can't really see the seams anymore. The only people who will notice that we added a new section are the people who spent the past few months working on it. It took a lot of hard work, but we are delighted with the result.
14 weeks after it went in for the mega pit stop, the Peter Pan is finally on its way to its home port, Travemünde on the Baltic Sea. In just a few days' time, the now 220-meter-long car ferry will start transporting passengers and vehicles to Sweden again as part of its regular service.